Hello, Internet people. If you're watching on YouTube, you can't hear the music in the background. The music in the background is my buddy Big John, one of his mix clouds from 2014, 10-year-old mix. Fun. Why are we frame ratey today? What's going on with that? Bitrate is kind of down. Frames? Hello? Is it, maybe it's just the camera. Let's do a little camera calibration here. Just a pile of garbage over there. All right, let's see. Focus control. Where's my focus control? Configure video. Camera control. Focus. There we go. All right. All right. Let's see, what else? I don't know if the microscope is going to need it. Sometimes it does. We're looking pretty good. That's not too bad. A little bit of tearing. And the other one was the arm, which is usually in a working state. Let's get the scope out of there for right now. And then do this. Yes, there we are. There we are, all ready to stream. Boy, how's everybody doing? I guess the streamers are starting to do Dragon's Dogma. I guess that comes out at 8 p.m. for anyone that doesn't have like a early. Try out experimental AI features. Get help writing, organize tabs, and creating. No. No, Chrome. I don't think I will. I don't think I'll do that. No, thank you. I don't want to train your AI. We just did a grocery shopping here and it was ridiculously expensive. Those prices are getting something else, aren't they? We're not going to start with this, but we will be getting to this, taking polynomials out of these wavetable equations in order to figure out what the hell is going on. It's like, what is going on here? And what I need to do is, I guess I need to set up the individual polynomials with default values inside of a program. So it'll run a function that will have the wavetable maker in it, basically, and it'll be sections of polynomials that you'll activate or deactivate. They'll become ones or whatever they need to be in order to cancel out. Ones or zeros, I can't figure that out yet, but I did take this polynomial out of the wavetable. I think it's this one. I don't know why it's going to here, but all of these had exactly the same first polynomial, basically. So we need to figure out how exactly this thing works and try to deconstruct and reconstruct it. And I need to figure out what the PWM equations are. Like, where did they get these from? Where did Hagiwo get these? Where did his source get them from? We can probably find an article pretty easily once we get to looking at it. I haven't had the time or the wherewithal to work on this. I had to do, paperwork stuff, and then the uploading, the constant uploading and creating thumbnails and marking down all the minutes of everything that happened. I'm burning out on it a little bit, and it almost caught up with present day. I'm only a week ahead now because I focused down and actually got all that stuff in. But yeah, it was for a little bit, it was like 2 days behind present day, which is scary. I'm supposed to be uploading every single day until I'm done. I've got 197 videos still to do. The original number was 350. Some of them have been skipped because nothing happens during them, especially working on the the wheel project. We're coding the wheel project is what's currently being uploaded. My collar's all screwed up. My collar's all messed up. We're currently uploading stuff about the wheel. And the wheel was an absolute struggle because of all of the Bluetooth low energy stuff and like all the procedures that need to be followed in order to fool this thing. And it didn't sound that. My collar's like really messed up. I don't know what to do about that. I think it's like super just messed up from the beginning. I don't think I can do much about that without an iron. Yeah. So the program was messed up from the beginning, and like, it's not that hard of a concept. It just needs to do specific things in order to get the wheel to communicate. And it was just a struggle for a while because the code was so incredibly complicated. And then when it finally boiled down into something functional, it took on like 3 different forms. And by the end of it, I had a nice, easy to follow, organized block of code and a whole algorithm to follow, but it was just so much. It was like somebody would ask what we're doing and it would take me like a quarter of the stream in order to explain all of the nuances of what we were working on and why we were doing it specifically in the way that it was. I should have just taken a, what do you call it? Taken the wireless wheel and just made a little LIN bus interpreter in there. Why is there so much delay on this? Oh, I need to check memory on this computer. Wait a minute. Wait a minute. How much space is left on you, C drive? Properties. Oh dear God, very little. It's only got 15 gigs of free space. Dun dun dun. Let's take, go to the desktop, go to weird porn? No, wait, where does that go? Recording. Take all of these. All except for today, which is the 0 kilobyte one, 321. We'll cut, and we'll put those in my drive, my D drive, which is this one. Where did? Oh yeah, this is. No wait, that's the wrong one. That's this one, stream storage, and then stream to YouTube. Actually, let's see how much is left on stream storage. I'll have to get another 6 gig drive. I got a terabyte of free space. That's not a lot. Uh-oh. View, details. Oh man, how much are 6 terabyte drives going for these days? It's gonna like tell me it won't fit. Well, it's only 200 gigabytes. It's not a terabyte. No activity today. What's going on? Everybody's gotten a life. Did everybody leave when I decided to skip a day? Everyone left. That or everybody's sick of the VCO project. Maybe we'll do something new tomorrow. Oh, here's extra lag. Woo. I'm definitely, the 2i2's talking. Desktop audio is very low. I'm going to up that a little bit. We'll go to like, yeah, 25% less than my voice volume. I got a bunch of follows 4 days ago. Ben Gizmo gifting a bunch of subs because I tolerated him. I get snippy when chat tries to remote pilot the streamer. I get snippy. Let's get on Streamlabs. I'm asking this computer to do a lot right now. Currently, what's going on with Burn the Subs is I am technically doing a I'm letting it sit with water in it over time to see if anything bad happens when we fire it back up. I want to do a test like that, and we have other projects that can take focus for just a little bit, and then we'll get back to working on Burn the Subs, because there's a lot of little things to do with Burn the Subs. We need to get a lot of stuff together, but I want to make sure that it's not going to leak. I really want to make sure that it's not going to leak, because there will be egg on my face if it does. This is totally hobbling my entire computer. You guys can see it in the frame rate. Look at that. It's so weird. What's up, Wayne Johnson? How you doing? We got a Thursday. We got a lot of work to do. We need to do some physical stuff today. We need to actually get into the VCO and correct the error so that I have one working VCO, and I'll order boards to make up for the rest of it, but I need to make sure that those 2 pins down there are flipped, and we can just do that quickly with a little piece of wire, and then we will have a platform under which I can get the VCO running and the code running. And I'm fully confident that I can. It's just we need to get into a little bit of the who, what, where, when, why, hows. I didn't expect to have to go so comprehensively into the code, but it turns out the code doesn't really function that well. It doesn't really function. Well, it does. It does. It's just coded kind of in a moon brain. It's like not very, it's thrown together at best. Actually, during the intro, I should probably look up a little bit about this. So it originates from Hagiwo and bases itself off of Xiao. This is a good set. This is my buddy Big John doing a closing set for a Costa Rican pool party. He has 47 whole followers. It's a good mix though, and it does give credit to the artists down there. So if you want to check it out, you can open it up on Mixcloud. Only YouTube, or sorry, only Twitch hears that though. Only Twitch. So wavetable 2 is like the final wavetable. The calling side specifies the waveform, frequency, and volume as shown in the code below. The first argument is the oscillator number. When you actually play it, it makes this sound. PSG type. PSG volume is a function of J, volume max over 4. They put 100 dot F. What does that mean? Is that multiplied? Star is multiplied. Or frequency of, no, that doesn't make sense. I don't know how this works. We need microcontroller experts up in here to read this. I want to find the math behind this though. Multiple sounds at the same time. That's going to be the chord VCO, and that's going to be a challenge too. That's why I haven't ordered any circuit boards. I want to make sure that everything is functioning properly first, and then we can actually order boards and I can get more into this. But we'll do a little bit of the software today, and we'll definitely fix the hardware today. What's up, Wonky Robot? Did that not come through in social stream? Cool. Cool deal, social stream. Thank you so much for not. Maybe it'll be a little bit delayed. Oh, it's up there. That one got it. My own social stream tab didn't. See that? Mine didn't get it. It hates YouTube. I'm going to reload it. You fucker. You bastard. Well, you got it up there at least. I'm transferring stuff right now, so this computer is slowing to a crawl. Oh yeah, I've been making thumbnails for my my stream, or sorry, my VOD uploads and stuff. This is like I had to throw out like 4 or 5 streams where all I was doing was coding and nothing happened. I felt so bad about those. Like, talk about feeling self-conscious about what you're working on, is when you spend a whole day writing software that doesn't work in the end and just doesn't get you anywhere. Like I didn't take a baby step with it. I put the whole thing together and it was just interpreting signals and stuff. Whoa, whoa, hey video, hey, okay, are we back? This is entirely my fault. I'm transferring 200 gigabytes of streams over to the archive drive. Luckily, these streams have all already gone up. They've all already been recorded on YouTube. Except for the one that I think I forgot to press start for YouTube. There was one like that. It's very quiet. I have probably 9 or 10 people watching me right now. So this is a good time to do this while we wait for people to gather. And we're listening to music over here on Twitch, sort of. This is just waiting. This is watching paint dry. Welcome to my paint drying stream. Actually, a paint drying stream would probably do a lot better just for the novelty of it. If like every week I did a swipe of paint and just had a camera on it constantly. I wonder how well the VODs would do for that. Somebody has to have already done that. Yep, there it is. It's all over the place. Watch paint dry videos and highlights. I would like to see a highlight from a paint drying stream. There it is. Watch paint dry. There it is. There you have it. Proof that everything has already been done. Okay, below is a brief description of the contents. First, the number of quantization bits and sampling rate of the audio to be output is 10 bits and 122 kilohertz. Video and sound are a little bit out of sync on YouTube. Yeah, it's gonna be like that while I destroy my computer. I think OBS is having a little bit of hold on. I guess I can't really show that. Let's see, over here we've got, oh, OBS is really struggling right now. 61 dropped frames. And we're apparently just using up a whole lot. Yeah, 34% CPU, 64 FPS. I told it to rely on the GPU a little bit because we got a 1080 FTW in this machine. But OBS is struggling because it's not the highest priority. The highest priority is this drive-to-drive transfer that I'm doing right now. What's up, Poopsie Doodle? What are you saying? You popped up in my YouTube recommendations. It looks like you do some fun stuff. Hey, thank you. Those YouTube things, I have tried to keep daily uploads going steadily, and it was a little bit of a struggle. I got to within, I think it was 2 days. 2 days until my daily uploads would be violated and I wouldn't keep up with it. But I have 197 VODs still to do. Want to borrow my hammer? Listen, if you want an American nut fucker, I've got one right here. My American screwdriver. What was this one? Oh, high-speed linear motivator. I did have, originally I had the anode and cathode marked off on this thing, but I guess my labels came off. But yeah, we had anode and cathode on the American screwdriver. So no, I don't need your hammer, I got one. A good Swedish nut rounder, yeah, exactly. That's mostly sockets. And if you need to leave just like a divot, a vaguely square-shaped divot, I have tools for that as well. You killed the dust bunny. Yeah, I don't know why there was such a big dust bunny on that. It's in a cabinet now, so it's no longer on the floor. I got this fairly nice cabinet funded by you guys, and now I actually have like tool storage and stuff. Because look at this, look. Because I'm electrical, I do electrical stuff, right? I actually have a drawer dedicated to programming shit and like electrical stuff. Like look, there's a little PCB in there. Not just like a tool, it's like a little piece, it's like my stuff is in there, not somebody else's. Isn't that crazy? And it's dust free, there's no dust. Because I closed the cabinet, so dust can't get in there. Yeah, this thing was not cheap, and I had to have it freighted in here. I probably could have gone to like Harbor Freight and bought one, but I decided to go with Grizzly because I knew that this thing would fit on top of it. This is my tool cabinet that needs revision. This one needs some going through to clean it out. And then this one just got all of the spillover stuff that I have in the shop, just like the stuff that sits everywhere. Even though this is still pretty bad, I've been working to get it organized and nice. Like, look at that, beautiful. That's beautiful right over there. I get to look over it in order to see you guys. And I just go, yeah, that's nice. Actually, these should go somewhere in that cabinet. Those are my hole punches. The US General boxes from Hazard Fraud are not decent, but they aren't as cheap as... Yeah, I guess everything's prices have gone up, right? Hardware fraud. That's a good one. I like that one. Yeah, I try desperately to avoid AVE-isms because back when he started out, I was watching his streams. That's why I've got the... danger not to be operated by fuckwits on my milling machine, but yeah, he kind of went a little crazy. But the problem is, like, if you go to his subreddit, because he's popular enough to have a subreddit, everybody tries to talk like him, and I'm just like, I'm not doing that. So whenever I say something like hazard fraught, that little gremlin in the back of my head, it starts pulling on neurons going, hey, stop it. So hardware fraud is a good one because it's not one of his. I like this song. This is Minimal House. Minimalistic House. We could also, what we could do with this is we could, once I do the fix, we could set up a listener on all of the inputs just to make sure that they're in the right places. Because this is a first run PCB, and unfortunately I bought way too many of them. They're above 100 millimeters, so I got charged like $30 for 10, I think. The overall order was like $60 to $70, and I'm gonna have to do another one now because I'm stupid. I left an op amp in the wrong way, and so I could either modify all of them or I could do another order. And how much is my time worth, especially if I'm making this many boards? we'll build up 2 test boards. We'll finish this one, and we'll build up another one of these just to make sure that I've found all of the errors. Because if you don't go over it, there's inevitably going to be an error there. Like right now, I'm fully confident that 100% of this board is totally fine once we do the fix. But if I don't check, there's going to be an error there, and it's exactly what happened to us with the with this run. Because this run on both of these, they have something wrong in the schematic, which is just an absolute nightmare. It's also a fix that is a little harder than it should be to fix. So I'm actually kind of distressed about this. Dreamsicle color. Yeah, these are the yellow PCBs from Seed, and I've now tried nearly every color. I haven't done white, but I did black for these, and I knew it wouldn't be that good. You can't really see the difference between the trace and the substrate, whereas these have this. It's not like not in your face yellow. It's kind of a warmer yellow, and it has a very dark substrate, so you can actually get good contrast and see all your traces. So I might do both of these in yellow and just start making yellow boards because I'm so happy about that. But yeah, I'm fairly distraught about this. Also, pet insurance isn't going to cover our doggie's tendon. We apparently, if we had the pet insurance for 1 more month, it would have all activated, but the orthopedic thing didn't on this leg. So now that they've got all this information, we'll not be able to have it get covered by pet insurance. It's obnoxious and fairly expensive. That poor doggie's tendons. I hope she's going to get better from what's going on right now, but orthopedic stuff takes, months and months. Hey, Mahalo, how you doing? Yeah, Willow's leg is still bum. She's limping on it pretty heavily, and I mean, I hope she gets better. I really do, but we might have to do surgery if she doesn't. Which is awful. The poor puppy. I mean, she like loves to run. She loves like hanging out with her friends and being a goofball, and she can't really do that. She's kind of just limping around right now. She has been able to see her friends and run around with them a little bit, but we shouldn't be encouraging her to do that. It's bad for her tendon, which is just heartbreaking. And she's almost 2 years old. This is like her time to like have fun and run around and. Back to equations. So, DA conversion using PWM basically only requires specifying the analog amount you want to output as the duty ratio of a square wave. Pulse code modulation and pulse width modulation. So you would have an amplitude or a period. Gotta love the way insurance companies do business. I know, we didn't get insurance planning on having the dog get injured, but for some reason you have to have insurance for like 6 months, and we had it for 5 by the time the dog got injured. Fucking ridiculous. I'm so mad. It's obnoxious. If it proceeds the way the vet feels that it will, she's likely to have troubles with her other leg in the future. So at least that'll get covered, but it's still such a fucking shitty thing. We're obviously, on the edge of our seats seeing whether or not she heals. It'd be nice to know if she did. But that tendon, like the body apparently doesn't heal that tendon or something. So, I don't know. Yeah, sorry about the audio. I'm doing this big upload right now. I discovered that my drive is nearly full. I record these onto the C drive and they're full 60 FPS, 1080p. We didn't used to do 60 FPS because the human eye can actually only see 30 FPS. That's not true at all. We only did 30 FPS because I was doing stuff in meat space. I'm not gaming, but for when I was gaming, we were popping it up to 60, and then I decided, you know what, fuck it, drives are not that expensive, so we'll just do 60 FPS for everything. And right now, my FPS is being humped by the upload. Both hard drives are running at their gnarliest. I have a carriage on the rack-mounted PC that I can remove the hard drive. I can just pluck it out of there and replace it with another one when it's full, which is soon, because I'm uploading 200 gigabytes and there's only a terabyte left on it. The human eye can only see 3,000 FPS. I mean, people confuse what a cinematic frame rate is and how the body and how the human eye interprets it. Not that recently, actually, as of like 10 years ago, animation was rediscovering smear frames and blur frames in order to get stuff to look like it's in motion properly. There's a whole science behind it for the in-betweening of frames and stuff like that. I have to glance over at YouTube chat periodically because for some reason my social stream blade, oh no, it does. It actually does show me. Okay, so I guess I must have fixed it. Cool, now I can somewhat trust social stream to do all my stuff. Social Stream is it's a Chrome plugin. I think it's also Firefox plugin, and you can basically specify multiple different windows that will show your chats, and you can amalgamate all of your chats into one and give it certain rules. I think I need to tweak this one a little bit because I need it to show me the system messages, and it doesn't really do that. I would like to know when somebody is subscribing on this page. This is my view. You guys, for the stream, get a different one that's opened through OBS, opening what's basically a web page. Yoink. Natural motion blur from the high frame rates. 3000 FPS is when you do a blip vert. Oh, nobody understands your max headroom references, don't even bother. Max headroom. Nobody remembers max headroom. That was even before your time. It's just my buddy who's Iron Pariah on Discord used to watch that. I'm well aware. There's music playing. We're in the pre-stream. I'm uploading a thing. Why do people feel the need to tell me these things? You have to understand that as a streamer who takes their job seriously, at least mildly, I am well aware of everything that I'm broadcasting, because you can get murked pretty easily on Twitch if you accidentally show like your whole C&B. I shouldn't be swearing this early into stream. I got to be careful. But like, you have to know that like it's right in front of my face, man. I know. Anyone who's streaming like this should have a window dedicated. I know I've seen some streamers just start up the software and put it in the background, but that's not what we do. I'm guilty of that, but it's also... I love max headroom 20 minutes into the future. I don't remember a lot. You could start a stream with chat bait widget. Hey, baiting chat is a time-honored tradition. If I was better at it, I'd probably be a better streamer. I know Rob Oz, as you guys know him, will periodically do like a dog shit political take, and you're not sure whether or not he actually believes what he's saying, but sometimes he will say things that are very intentionally baiting chat into being appalled at what he's saying. Yeah, the Max Headroom pirate broadcast. I only learned about that a couple months ago. Maybe more than, maybe I think it was during the pandemic actually is when I learned about that. It was a good read for a little while. That shit was cray. Please, hurry up and finish uploading. Please, please. 20 minutes. Well, we'll intro for that. It'll be gone before you know it. I don't know why it slows down like that. It always starts up very fast and then it slows way down. I guess caches or something, like empty out. I don't know. It's going from an SSD to a platter drive right now, and then this computer is desperately trying to record an MKV file for today's current stream and what's being recorded right now, right? In case things reset. Heard the name Max Headroom, but I have no clue what it is. You can just Google it. It was just like a TV thing, just a weird show. And then there was a guy who hacked a TV station with the identity of Max Headroom. He had like a mask on, and I think he showed his whole grundle or something like that because he was disgruntled. I actually forget a lot of the details of the story, to be honest. I had to somehow figure out what the hell's going on with this and all the sine wave stuff that's being calculated. This is translated from Japanese, so... 10 bits, frequencies that. By the way, the digital amplifiers use PWM to use frequencies from 250 to 1.5 MHz. Digital amplifiers that use PWM use frequencies 250 kilohertz to 1.5. Maximum value of the duty ratio does not necessarily need to be a power of 2 in order to play audio with a predetermined quantization bit number, sampling frequency such as 16 bits, 44.1 kilohertz. The sampling rate must be set in any case. You'll need to redo the conversion of quantization. Pico Extras is PWM audio. Here we go. Sampling rate conversions and dithering using an interpolator. I don't think we're using that though. Watch the show, it's amazing. The one I remember was, oh, I forget what the name of it was. Oh no, yes, I remember it. Sledgehammer. That was one of my favorites from way, way back in the day. The satirical police show where the guy's in love with his gun. Was that Sledgehammer? I think it was. The reason my Windows is in light mode is I have very good reasons actually. It's because I have this thing in my face, and this is my soft light. You'll see a lot of streamers using these things, and for me, I mean, I'm not following the tutorials that I was originally listening to. The oh, I forget the guy's screen name now. Damn it. What is that guy's name? Crap. It's in my YouTube. But anyway, the point is I have a light behind this thing and then a diffuser in front of it in order to give us nice, soft, non-hard shadowed light. That is necessary so that my face shows up properly on camera, but it's also right in my face. So I use light mode because my pupils are tiny and I wouldn't otherwise be able to see text as easily. That's the reason behind light mode. It was primetime TV, couldn't go against Dallas, but maybe Saturday afternoons. Yeah, that's right. I don't really remember much about the show. I think there was a movie that I must have watched. That wasn't very good. Also was not very good. But I keep referencing blipverts and nobody gets it. This thing's getting nice and toasty. We have all this Canadian air coming down to Philadelphia right now, so it's actually 0 degrees Celsius outside, and boy, it's not really that welcome. It's like sunny and nice, but super cold. I mean, it's a little bit more seasonal, to be honest. It's not supposed to be warm this season, but it is very suddenly cold, and so I'm shivering a little bit in here right now. Contributing to the heat in my shop is this scope, though. The scope does not run cool. This is a hot scope. It's doing a lot. It's basically a tablet with some knobs, but Rigel did a very good job putting it together. We're almost there, about 75% of the way through, as I look at equations and stuff. We'll do the soldering first because that's a much more satisfying draw for people to see. I'll get more people in here, and then we'll bore them all by going back into this stuff. Pico Extras, Pico Audio PWM. ST-DARG. String, STDIO, hardware, GPIO, DMA, PIO, IRQ, multi-core. Oh. Audio PWM sample ending. PWM PIO.h. PIO. Audio PIO, and then this sets up a bunch of this stuff. Enable PWM assertions. This is different from what our code is. Audio buffer pool. PWM channel config. What else do we have? We've got a buffer. Yeah, this is totally different from our code. When we do pull up the coding window, that is in dark mode at the very least. I guess my switches from dark to light mode can sometimes harm my viewers. I'm on the East Coast of the United States. It's bright out right now. You can see all that light behind me. That's how bright it is outside. It's that my camera's like overloading. This isn't going to net us anything. I don't think this is going to help us out. We'll have to review how this thing works and then see if we can pick out what this polynomial equation is doing, because this is where it defines its different modulation types, and it's doing something to produce PWM output on P2 that then gets filtered into actual audio waves. And I think it's pretty good at what it does, but we'll set up so that our test program can run just a simple wave output, and we'll take a look at that on the scope, and then we can start playing around and trying to figure out what that equation derives from. Like what is the master polynomial that's creating all of these waves in this modulation scheme, and that way we can pull stuff out of it and make it more universal so that we can have a program, or a function rather, that will assert that modulation type with the parameters specified for the mode that we're in. Simple. Very easy to explain. Everybody totally understood that entire thing. I probably won't explain it as good too when stream starts. That's the problem. It is cold. It is cold here. I am cold. I've ordered some stuff for the RC car project. I think that project is really pretty much done, except for finding like a body for it. And I don't know what I want to do with it, because there aren't enough whimsical bodies for these 1/24th scale RC cars. The problem is I don't have any kind of like a social network that supports my man-child, my giant man-baby RC car habit. That kit was expensive. It was a lot of fun to build. It was a fun stream, and I've got it all together. I'm going to get wider tires on it and see what top speed I can get, and then possibly detune it a little bit so that I can actually race it around. But putting a body on it sounds like an interesting challenge to get one to 3D print, and I've tried it before. It uses up like a quarter of a spool per body. It is a not very efficient print. Maybe I can try to find, I don't know which slicer it is, but one of them makes these branching paths as support material. That might be a slightly better slicer to use for the car bodies. But then everything is in layers, so you have to like sand it down and get it smooth. It's a job that's better suited for resin. And I don't have a resin printer at all. To have a resin printer, I think Twisted Sister had one, and he was like, "Do you want it?" And I'm like, "I don't really want resin in the shop." I should have said yes. It would have been a good painting project and stuff. We could have printed out a little tiny car body, and of course then I'd have to deal with all the fumes. That's the only thing about resin, is you got to deal with a lot of fumes with resin. A lot of alcohol, a lot of fumes. This could not go slower, huh? But yeah, a Short Lurker found a what is it? It's like something or other 3D site, and he found a person that does 1/24th RC car bodies, just as like they just do that and sell them for $1 each, and then you deal with printing it and everything. And since these 1/24th scales are completely outclassed by their motors, like the motors that go into these. Cura, that's Cura that does the tree support. I gotta look into Cura. The little 1/24th scale RC cars, the batteries and the motors are way overpowered for them. Just the universal motors, the little Tamiya motors, those are enough to power a 1/24th around. And I've got like a 3-phase huge ass motor. Like you can outpace your RC car with that motor, and it like. You just spin out at whatever speed. So like the cool thing is, that being a given, having a heavy car body over it, a big plastic body, is not a detriment to the speeds that you're going to achieve, because you're still able to get faster than the grip of the tires. It's like at a certain amount of accelerator, you're just on glass. But it would be way more fun if I could buy a bunch of workout those workout foam puzzle mats. Why is this not updating? I think because my computer is so slowed down. Chrome must be like really restricting resources or something. Because, yeah, chat didn't update with Wayne Johnson's comment. Or Poopsie Doodles. A dedicated space would be great for resin printing. Yeah, you're absolutely right. Yeah, there's 2 messages that just straight up didn't go through. It's so weird. Oh, maybe if I open up it probably, no, there's that one. Strange. Sometimes the windows, when they fall behind and I click around at a lot of stuff, they'll lose memory like resources, and so they become background, and then they don't update for things that should automatically happen, like chat going over to the social stream blade. Back you guys up. This is the whole setup here. This is what I stare at. This is the furniture that I yell at when I stream. I sit here and I yell at the furniture all day. I like having YouTube all the way over there just in case. And then this is the monitor for Twitch, where I can also moderate, but that one isn't where social stream's coming from. Social stream needs pop-out windows in order to give me chat, and it just straight up misses stuff. So now that that's happening, I have to have these 2 in front of my face so I don't miss comments. We're getting there. We got 45 gigs to transfer, and then we'll start up. Make sure the music is... I got plenty more music. Good. Good. Where's the actual stream? Oh, that's over... Wait, that's in this one. The YouTube stream is here. So if I need to moderate anything, which I haven't had to do. Don't play that video. No, well, if the messages are going away on your side, that's different. The social stream thing that puts it up on screen is what's... Wait, okay, so the OBS one is running right now, but this one isn't updating at all. Yeah, no, it's not you, it's me. Right now, the file transfer is taking up a lot of the computer's resources, and so things aren't keeping up. But once that's done, things will go through just fine. And then we'll get into modifying the VCO. We'll probably have to use hot air to get that chip off of there without damaging it. Oh yeah, I'm all out of sync, so I can't even dance along with the music because you guys will be like, what is he doing? Why is he moving his body like that? There's no audio. That's what my ex said too. Yeah, indeed. We still have to make something for Julian using this thing. This is a pretty cool little device. What this is it's an XY pad that also measures how hard you're pressing it down. So if you put something like a mouse pad over top of it, you can move your finger around and you can get all these inputs from it, including pressure. So you can make it like a little keyboard or something like that. This was a sample. I forget how much this costs. Why is there, I have like a splinter in my arm now, in my palm. What the hell? It really hurts. What have you done to me? I think I got it. Anyway, so yeah, you can press down on this and get X, Y, and pressure. We need to make that into some kind of a filter. I don't think it'll, I mean, it's a little big for a modular synthesizer, but it is kind of like the perfect thing. We could make a module that's this wide and has a couple control knobs up at the top and still, oh, actually, never mind. We can make a thing that's just this pad because this is the size of the rest of it. The fiberglass handle and hammer. It's got a rubber thing on it. No. There's just chips all over the place from all the projects that I've been working on lately. It's not out of the realm of possibility that there would be an aluminum chip that was like on the corner of the mat. But yeah, this thing will make a pretty cool module. We'll just have to put like a microcontroller on it and have it output. I don't even know. This could be the controller for my, like the controller for the synth, like the, you know, making control signals, note signals, 1V per octave. Not really sure how the rest of it will work though, in terms of like pressing something and having something happen. I guess you could do X pressure, Y pressure, and do like an XY. And then it would be up to the user to decide how they wanted to use that input. And it would go from -5 to +5 volts. That did not end up in the bin. I threw a seltzer bottle, and it careened off of the edge of the bin, fell to randomness. That thing, the fart box. We need to get that running again. I need to get into Node-RED. I also need to get into Node-RED for the pepper plants that I'm going to be planting. I need to turn a grow light on when the sun goes up and down so that I can grow them in here. I can start them out in here and then move them over to the deck when it gets nice and warm out and get a head start on the peppers. It's not quite, it is getting on the season, but the peppers won't grow unless they're in like a 70-degree environment. So, but that's this. We're in 70 degrees right now. Actually, it's a little below 70 degrees. It's kind of cold today. Kind of cold. I got some more habanadas, as in habanero, but no spice. I'm hoping these ones grow this year. A piano synth that uses this touchpad so you can do tremolo expressions on the keys. That's cool. I think Julian told me about that. I know Hans Zimmer has one. I saw one at Hans Zimmer's studio. But yeah, it's basically a mouse pad over that sensor, so we could totally build that. Although not having, because all of my synth stuff is 3D printed, I don't know about whether or not it'll support properly. Because the PETG that I use for the 3D print, while it is solid, I don't know if it'll tolerate me poking it with a finger. It might be okay with it. Maybe if I put like support behind it or something. But yeah, this is getting up there as the maximum size that one could fit. It's actually kind of perfect for a modular synth. Look at that. The only problem with it though is that this is dead space on the sides. Look at that. It looks like it was designed to fit a modular panel. Huh. Well, that could be a little DIY one there then. But the problem is, where do I put the ins and outs? I'd have to put something next to it that has all the ins and outs because of all the wasted space on the sides. If there's an open source K-oscillator, sorry. The K-oscillator was okay. Julian had one for a little while. I guess he gave up on it. Plug and play module. I don't think so. No, I mean, you would just have like a button on it that would change modes. Just a button that changes modes. But yeah, this would be perfect. I should work on this at some point. Get a nice frame going for it, and then make a back panel that would support on the front panel and have a side piece. So this will probably, it's probably not gonna, it does take up exactly the space. It would probably have to be just a little bit wider so that I could support everything. Oh, our file transfer finished. All right, so let's do a little checkup here. Are things in sync now? Now on YouTube, the audio should probably be in sync if you've got a good connection. Click, click. And then I'm going to go to the Social Stream Blade. I'm going to reload it and then click over onto the chat window there. And then chat window here. Force and please should show up. It's not showing up on my blade for some reason. This one. Safety glasses when powering on electronics the first time. Oh, there we go. Now it's propagating. Powering on electronics for the first time. On what level? Like something that you've built from scratch? And if you've built something from scratch, you should be confident enough that nothing is going to actually explode. In addition to that, you shouldn't be putting your face anywhere near any things like capacitors that would actually violently detonate. Not to mention the fact that capacitors shouldn't explode. They should outgas more than anything, although they have been known to violently explode, and my most viral clip involves a capacitor, but that was because we gave it way too many volts. We gave it like 50 volts, and it was a 30-volt capacitor, so obviously it popped off pretty violently. Generally, electronics aren't supposed to be that violent. You know, we're not all, what's his face, electro boom. Okay, computer resources freed up. Let's get Start Soon out of here. Let's get the music out of here. If you can't hear music, you're probably watching on YouTube. But this is a set that my buddy did at a pool party in Costa Rica. That's a pretty nice little chill time. We had to do a big file transfer there because my streams are rather large and they were clogging up this hard drive. So you don't put everything in its case and tighten down all the screws before powering it up the first time. No, you really should take it step by step. Where is YouTube link? You don't want the YouTube link. What are you talking about? It's my VOD channel is where the YouTube stuff is, and that's at @bother_VOD. There's no underscore between bother and VOD, but you can just use like the VOD command, I think, in order to figure that out. It's my VOD channel. It's where these streams are going up right now, and it's where I'm also uploading daily uploads of the 350 streams that did not make it to YouTube, going from early in 2022. Right now we're in January, February, March, April, May, June. We're in June of 2022. And I think we're about to get a dog in terms of what's going on in my life during these streams. I don't know if I've gotten a haircut since then. I should probably... One of the things that I was supposed to do this week when I had a total and complete executive function meltdown was to get a haircut. So clearly that went well. I will eventually. I'll get that done. I gotta work on waking up early again is what I gotta do. I've been sleeping too late. I've been slacking. But those daily uploads are still going up. I'm about a week ahead right now, which is, well, half a week ahead, which is good. It's still a little nerve-wracking. We didn't stream on Tuesday. I forget what was happening, but life stuff kind of just got in the way, and I was not feeling up to streaming. I'm back. I lived. And what I'm living for right now is this voltage-controlled oscillator. In a modular Hagiwo synthesizer thingy, you have modules. Obviously, the modular synthesizer has modules. Though I feel that is very simplistic to state, it is worth stating because someone will ask. This one is called Crimes. It's responsible for doing all kinds of little crimes. One of their main crimes is the crime against microcontroller code, because apparently you can't get the Teensy 3.2 anymore. If you are building specifically the Crimes module, you can contact Paul Stoffrigan. You can send him an email. He's the guy who built the Teensy 3.2. He has end-of-lifed this chip because, although this platform, because of limitations in supplies, especially during the pandemic. But that means that people with crimes weren't able to make their crimes. He says you can contact him and get one of these if you feel so compelled. However, there's also a fairly large DIY effort to use the latest Paul Stoffrigan John, which is the Teensy 4.0, to power crimes. Anyway, the point is, modular synthesizer, you have modules. Modules do a variety of tasks. They can either be your input, so you can be twiddling a knob and affecting something. They can make audio waves based on voltages. They can create those voltages with patterns. They can take external inputs and output audio and filter audio, and just anything you can think of to do with audio can be done with modulars on a modular synthesizer. The thing is, like, synthesizers have sort of a fixed progression of things that they do in order to make sound, and people decided, well, why don't I have this thing available to me externally? And so that's where modular racks came into play. This is a Euro rack, so these are a standard size, a little over 100 millimeters, and then a certain number of units wide. So we've been working with that and the 3D printer, and the fact that you can buy circuit boards, and the people who make the circuit boards say, good luck, asshole, and don't give you any help at all. And I like that because that allows me to be clever streamer boy and actually put together these modules as I see fit. It's been a lot of troubleshooting, it's been a lot of testing, it's been a lot of soldering. The soldering is the fun part, but the discovering what you didn't solder properly is not the fun part. However, I ran into, thanks to Speedy Cat, who's a frequenter of this stream, thanks to Speedy Cat, I ran into this fellow on YouTube that you guys should all check out. His name is Hagiwo, Hagiwo. It's exactly as you think it would be spelled. Hagiwo on YouTube creates cheap modular synthesizer modules, and he does a lot of really cool work, and he does it for like under 10 to 20 bucks for each. This is a $350 module. I don't know how much anything else here costs, but I know marbles is fairly expensive. Part of it is that it's been discontinued. But yeah, these are fairly expensive when you put these things together on a professional level. Why would we do that when you can build a $10 module? And so what I've done is I've taken inspiration from Emily Gillette. I don't know how to pronounce the name, and I unless I get somebody in here to physically correct me, I will continue to pronounce it as I see it. It's Emily with an accent mark over the E, the second E, so I don't know. Anyway, using the concepts and circuits from marbles, we were able to apply them to a Hagiwo circuit and create something that's a little bit more involved than just having passives on each microcontroller output. Now, while that does, I mean, it doesn't really drive up the price for us because it's op amps. Op amps are so universal. It does give us a slightly more professional circuit and everything. The second case to the right is the second case that Julian had that he gave to me. He gave me that one for free. And what I'm going to do is I'm going to take the power supply from my main one, the power distribution module, from the guy that I shouldn't have ordered anything from because apparently he's like a turbo asshole, like turbo super asshole. So I'm going to take the power distribution module, move it over to the other one, and then have a 4-pin cable between the two. I have some really nice connectors that I want to use in some things, so I'll use those. And then I'll have the one power supply that is way overbuilt. I used Pololu modules in the power supply so that I have a lot of 12 volts, I have a lot of 5 volts, I have a lot of negative 12 volts on that board. So what I'll do is I'll take those voltages to the other side, and then I'll have both of the synthesizers powered off of one 15-volt power supply and plenty of current for both of them. And one of the power distribution modules is enough for one case. It's there's a lot of plugs on that thing. Where schematic? What? Well, anyway, Hagiwo created, now I still have it open, yeah. Hagiwo created this VCO here, and this is a single VCO. It's a single channel VCO that I would like to have a bunch of. But single channel VCO is obviously only going to make one note at a time. Why is this stuck? Damn it. Hold on one sec. I gotta reset this one. Yeah, thank you. Wait, Solder State? Is that him? I thought it was Hagiwo. What page do I have open? Yeah, thank you, Wayne Johnson. Appreciate you doing that. Yeah, it is Solder State. Okay. Yeah, note.com/solder_state. And you can also look up this name on YouTube, Hagiwo. Sounds like 3 kanji make up that name. I don't know what it means. But yeah, he's got a lot of really cool circuits on there. And this is the singular VCO. So you've got a couple controls going in. You have control voltages going in utilizing, I guess Schottky diodes or something in order to limit the voltage that's coming in. We use a slightly different method. We use the mutable instruments method, which is to have a -10 reference coming in. We have a -10 reference on the board, and what that does is that shifts a 5 volt to, where did that go? Come back here. -10 volts applied to a +/- 5 volt will then shift the voltage down from -5 becomes 0 and 5 volts becomes, 5 volts becomes 0 and -5 volts adds to the -10 and becomes, wait, that doesn't make any sense. Hold on a second. -5 to 5 is a 10 volt swing, and we're shifting it using another 10 volts. We're shifting it, and what that does is it goes into an inverting amplifier, and then it is cut by 1/3 with the 33K resistor, resulting in a 0 to 3.3 volt signal. And if you get out of that -5 to +5 volt range, this amplifier cannot go above the voltage that it's being given, aka 3 volts, 3.3 volts. So this will not blow up your microcontroller, which is why I wanted to use this in our circuit. So this is what it's reading from, and then we have an output, and the output's a little bit more complicated. Let me refresh my social stream thing. Where did that go? Chat program properties. Can I manually refresh? Yeah, refresh the current page. There we go. Okay. So with our chord VCO, we could use this low pass filter that Hagiwo uses, and that's just a couple resistors and a couple capacitors going to ground. Exploding MCUs make life interesting. These are RP2040s, so these are $5 each. I just don't want to see a $5 MCU go. I had on the mutable instruments, speaking of supply chain issues, on the mutable instruments modules, they use an ST micro, a very specific ST micro chip that's 3 volts only and has 1 billion pins, right? It's this huge extensive thing. Because of supply issues, they were $14 each, and I blew one up. It was an instant $15 that I just gone by giving it 5 volts at some point. Everything should be 5 volts compatible, but you can't always win those. Everything's going to 3.3 volts, and then in a couple decades we'll be at 1.4 or whatever that other standard is. But anyway, for right now, it's a sacrifice to the electronic gods. I have an entire bin that's filled with fucked AT-Tinys. AT-Tiny 85s, because I kept blowing them up. It happens, like, you know, careless stuff happens, especially when you're streaming content and you're expected to be punchy and interesting. You forget to be boring and slow. So what's going on with this thing is that we can't have direct audio output out of the RP2040, but the RP2040 is so affordable. So what we do is, instead of outputting audio, we output a high frequency PWM. So a PWM is a pulse width modulated signal. So you're determining what the pulses are, and it's just a big square wave, right? But when you output that high energy square wave and you limit the duty cycle, as in how much energy, how long are your width pulses, right? And you have a certain amount of energy in those width pulses, you apply them to a filter of some kind. In this case, it's a low pass filter. This is a Sallen-Key low pass filter. So Sallen-Key filter is a little bit more complicated, a little bit more controllable, I guess, and involves an op amp. But what we get on the other side of that is a wonderful audio wave. And we discovered that I did this backwards, because this symbol looks the same for the different structures that you have, a Sallen-Key filter or an inverting amplifier. The symbols look the same, but sometimes people get a little silly and they flip these two gates around, and I neglected to notice this, and it cost me $70. That cost me $70, that little mistake right there. You guys ever made a mistake that cost you that much money? I think I made a $500 mistake before. That was a fun one. $500 mistake of buying a part for my car that wasn't the right part, and there were no guarantees on it. So I have all of these boards, and they're all wrong, and they probably should get thrown out, unfortunately, because they're not the right thing. And I will order the exact same number of boards. We'll get one of these working before I declare it, but yeah, that's an expensive mistake. Also, these are just off of 100 millimeters. The next modules that I make should be 100 millimeters tall, so that I can actually order in with the Seed Studio service and not have to pay a little bit extra. Resell them. I would feel bad reselling, because although we did take an amalgamation of two different designs, it's still other people's designs. You know, Haji was the one who went in there and said, hey, I could apply this to an RP2040 and make a cheap little VCO out of it. So mostly what I was going to do with these is just have a ton of VCOs. And maybe I should just do repairs on all of these. I'll just run one wire, and then I can have a ton of VCOs that function. 60 amp, 480 volt, 3-phase line to the output of a variable frequency drive. To the output! Oh, $3,000. Was it company funded at least, or did you have to eat the $3,000? That's a rough one. That's a sinking feeling that you get. I had a one-of-a-kind, irreplaceable, terrorist-made GPS that I was studying for my old job and doing a whole write-up on, and I tried to power up the backlight on it, and I hit the little transistor with a very small voltage, and it blew out the entire screen. The LCD screen no longer functioned. Luckily, I had gotten all the pictures I needed to get, but I wasn't able to show that it has backlight functionality. That was embarrassing, because we passed that off to the next, whoever was going to study it, and I never saw it again, but we here, this is a broken thing. Oof. The input and output were swapped between the new and old units. Had a brain fart. I'm self-employed, so I ate it. Ooh, that's a tough one. Damn. That's not exactly a show up at Micro Center and buy a new one and then swap the cases. So the Salin bandpass filter in our software is fed by a bunch of equations, a bunch of polynomial equations that involve sine waves and stuff. And we need to get to the bottom of that. Before we get to the bottom of that, since we have code in here that is working, oh, and this is us just figuring out, this is my stream of thought notes here that I'm getting rid of now, but this was us trying to figure out why the waves were doing weird stuff. And the reason is because the pluses and the minus are swapped and I didn't notice. I could have saved myself so much time. So what we'll do is we'll do the physical repair. That's going to take us only a couple seconds. I got to pull the chip up, and then we can do a little troughing and a little bit of soldering. Resell it as a necklace. I was giving them out at one of the festivals that I went to with that giant theater globe that we put LEDs on. Boy, oh boy, that project should have gone in a much different direction than it did. I was dumb. I was dumb back then. But that globe was pretty cool. I mean, we had it on the USS New Jersey, which incidentally is actually being moved. Yeah, it's been on the move for an hour by a couple tugboats. So the USS New Jersey is being taken over to dry dock, I think, for a bunch of repairs. They had a couple sailors on there. Hello, hey sailor. But no, they had a couple sailors on there who were absolute fucking dickheads. They were so mean to us. We were there for a costume party at Halloween, and they were just being total dickheads. I mean, their job is probably to protect the museum front and stuff from a bunch of hedonistic assholes like we were, but they could have been a little nicer about it. But anyway, we had that big globe hanging there, and that thing, that thing was crazy. But the direction that it went in was weird. We should have just done like addressable light strips for the whole thing, but I was insistent on trying a couple different methods. I forget where that story came from and why I was still telling it. All right, I'm gonna save this. Oh yeah, because of the way that project went, I ended up modifying about 600 3-watt LED drivers and attaching them to circuit boards where they would power the LEDs. And so those circuit boards are very simple, just routing circuit boards, and I ordered like 100 of them. So I had a bunch left over. It was like one of them stored 4 pixels worth of LEDs drivers. So those things, I had a bunch of PCBs left over, so I was handing them out as keychains to everybody. How do you know what values to use for your components? We have the advantage of Mutable Instruments actually closing down their whole operation. Mutable Instruments stopped doing the whole modular synthesizer thing. I think it took a toll on her overall well-being, and she decided that she was no longer going to make new modules. But in doing so, Emily Gillette was a saint, an absolute fucking saint, and released all the information on all of her products. And what that means is that we get circuit boards. Now, it means you are never to contact the person. We had a user in here a little while ago that was insistent on contacting the person who made the PCB in order to ask the questions that I was having, because I was struggling with putting them together. They're very small, very complicated, and very difficult to build. That was the whole point of it, and the point was to struggle. But the struggle got to my audience a little bit, and they kind of leaked out into the real world and claimed contacting some of these people, and I was putting the bosh on that as hard as I could, because you're not supposed to contact these people. The fun in building modular synthesizers, like if you want to, you can buy a kit and everything is assembled for you and it's nice and easy. I didn't want nice and easy. I wanted a $10 circuit board and just to be released into the wild and figure it out on my own. So, but what Emily Gillette did is release all the information on their products, and that way you can go to some other website and buy the circuit board. Troubleshooting's half the fun. I was tearing my hair out. I actually, a YouTuber named Toil helped me out massively with the questions that I had. But yeah, in getting the physical circuit boards, and these are all in Fusion 360. That's an even better part about the Emily Gillette files, is that they are already in Fusion 360. So you can open them up in Fusion 360, and they have schematics. And so the values for the components I derived from the schematic diagram. And they're nicely laid out. All I had to do was figure out a little bit of the maths involved in order to make sure that I'm using the right thing. And the whole thing about this is the RP2040 is a 3-volt microcontroller. The STM32F405 is also a 3-volt microcontroller. I was lucky enough that I found I think it was a different circuit than this. I found a different module that actually did use PWM in order to create audio in the same scheme that we're doing. But these are nicely laid out, and all the components are there. I even stole, I stole a component. I stole the potentiometer from Emily Gillette's files, and I put a 3D model on it, though. What's up, Athanor? Okay, no activity on YouTube. Just I have to glance over at that every now and then. I'm extremely noob in this world, but thanks for explaining. I know nothing about nothing, man. I know nothing. The thing is, like, I haven't done analog stuff. I do a lot of digital stuff, and we're fairly good at that at this point. I'm mostly having chat IDE, so that when I'm programming, chat is like real-time correcting anything that I'm doing. It gets on my nerves, but it happens, and they do help you. They help me, at least. They helped me learn Python in record time. I cut my teeth on C code, and then in college we did a little bit of machine language, and I took a C++ course, and so all that went together with Arduino, and I ended up learning mostly Arduino. So do you have any nice book suggestions? Why do you always ask me these, Hidanika? I do like these things coming out of left field, though, to be honest. Book. That is the which one is that? Oh, the Forrest Mims books from 1995, 4 or 5. That's what I learned on. I don't know if what you would find is anywhere, like, there's so much digital electronics now, like microcontrollers and stuff. One of the first things Forrest Mims teaches you, like in all of the old electronics stuff, is they're like, oh, you're getting started in electronics? Let's get a 1 to 10 transformer and plug it into the fucking light socket. Don't do that. If a book suggests that your first electronics project is plugging a transformer into an electrical socket, you put the book down and you walk away. You just walk away. Let an adult know where the book is, because that's utter nonsense. These days, we have digital electronics. We have 5 volts and 3 volts, and we have kits galore. So the reason I link to that book is not necessarily for you guys to get started. If you're looking at some of the fundamentals of analog and stuff, that book is really good. It'll teach you a little bit about what goes into electronics, but from there, you will need to branch out on your own and find your own sources for beginners stuff, because everyone and their dog has put out a beginners of electronics book. I would love to do one with like my attitude and just being a little shit, teaching people how to do basics in digital electronics, but that market is saturated. There's been a lot of stuff. SparkFun was really good for learning some stuff. The way you learn is to burn. Well, okay, so stuff will happen. Accidents will happen. You're going to get burns on your fingers. Something will pop and it'll scare you to death. But eventually you start to get a handle on everything. This is all math. All this stuff is math and structures that are known ahead of time. A lot of the time in a lot of engineering, and this is one of the big things that I teach about reverse engineering, like beginner electronics, my ass. The biggest inspiration for figuring out how a circuit is going to work is the data sheet for the chip. There's a lot of different, like, hey, I'm trying to do this. And you're like, oh, let me look through these chips and see if I can find some. Oh, this chip does it? And you open up the data sheet and it says, here's how you do it. Here's the circuit. And you're like, oh, okay, there's the circuit. That's all I need to know. And that's a lot of what happens in engineering. So when you're reverse engineering something, when you're trying to figure out how somebody built something to work in a particular manner, you go to the data sheets and the application notes, and you can find everything right there. That's generally how it works. And a lot of engineering, a lot of electrical engineering is saying, I want this to do this, so I'll put these two things together and I'll get chocolate in my peanut butter and it'll be delicious. That's electrical engineering. So where did I get these values from? Somebody else's design that does the same job that I want to do. Started playing with line voltage as a small child. That was a story that one of the test engineers told me. Actually, I don't think he was an engineer, but he told me a story about his friend who's like, hey, you want to hear what electricity sounds like? And he takes a speaker and immediately plugs it into a wall and it just goes, and then explodes. Or just smokes, I guess. It lit on fire because the coils couldn't take 120 volts. But that's what 60 hertz sounds like. It sounds like breaking. That is the wrong one. There we go. As an electronics consultant, we're basically applications engineers. Yeah, that's what a lot of people wanted me to get into too. They were like, oh, you're a systems engineer. So you basically just plug things into each other and then put it all on the wall. And it's like, oh, okay. I did robotics, which isn't exactly systems, but a lot of stuff wanted me to get into systems engineering. I went into electronics just because the job title, reverse engineering terrorist electronics. I was like, fuck, sign me up for that. Make sure to also ignore the line that says not for new designs on any datasheet. Oh God, yeah, that's actually a relatively new thing. In high school, I used to go to the library and print out datasheets. The librarians hated me. I went through so much paper. But the not for new designs thing, yeah, it's nice that DigiKey tracks that. I guess some of the other places do too. You can even search based on that. So yeah, this circuit is just derived from an Emily Gillette 3-volt into analog input circuit, and then the the Sallen-Key filter we also got from a Gillette design. And I don't know how I lucked out with that one, because at the time that I actually got that, I thought that it was an audio circuit. I thought it was taking audio in and amplifying it, the Sallen-Key right here, but I happened to luck out and find the exact correct circuit structure. I've heard of Moritz Klein. I have heard of Moritz Klein. If not from you. No. Emily Gillette is Mutable Instruments. They are a transitioned girl, and they changed their name. So if you look at some of the older circuits, you'll find a different name in the margins, but the spelling, as far as I'm concerned, is like this. So it might be Gillett. Maybe I should be saying Gillett. I don't know how to pronounce this, and I'm sorry if I get it wrong. Mortis does from the very basic to advanced. Do they do an explanation of how the circuit works? Because I think I listened to one of their wonderful. Is that also the one with the alien logo? Because I think I'm already subbed to that person. I think I actually am. He does, yeah. So I've definitely listened to some of those, and they're super inspiring. He's just like, well, if I recall correctly, he's just like, oh, well, that didn't work, so we put this structure here, and we decided to put this there in order to filter out this specific thing. And it's like, whoa, I suddenly understand analog electronics for about 10 minutes until I walk away from the computer. And then suddenly I forget everything. So anyway, we incorporated these designs into our own VCO. And so my schematic is one page, and it just looks like this. And so we have an input structure, and then we have an output structure, and that's it. So each RP2040 has one job, and that's to create PWM that will then filter down into regular audio. I am very, very lucky that Emily Gillett, there we go. Whew, that's going to be tough to redo those neurons. Emily Gillett did the exact same thing on her, I forget which one it is. It's one of the other circuits. It's not Marvel's, but one of the ones that outputs audio, they did this with. So I would very much like to do the same. We need to actually vet out that all of our stuff works. So we have two tasks today. One is going to be fixing my fuck up. We're going to be reversing the pins 5 and 6 on this TL072 will enable us to have the PWM properly going in, because with these reversed, it doesn't actually output anything. And we did a little bit of work to test that it would output if we put the right thing to the right pins, and it looked like it did. So let's do that fix first. And I'm still in the debate about whether or not I want to run another $70 to flip this connector in basically the silk screen only, and flip these two pins. I don't know if that justifies a whole new board, because we soldered the power connector in upside down, because it's a square connector. Everything on it is reversible. Analog is more fun with tubes. I would like to do something with tubes in the modular synthesizer space. Noritake, again, with the frickin' pronunciation. I need an AI. We need to put... So we need to put... Hedonica, don't tell me what to do. I need to put an AI in this thing that'll give me the pronunciation of stuff. That would be a good use of this. We also need to make it into the fart box. Where'd that eyebrow go? Why is it missing an eyebrow? It's a little creepy. But you don't like Furbies? I think you do. Okay, put him back up here. Furby GPT. I can't. During the time when it's interpreting what the command is, because you know how AI is. You ask, hey AI, what's this thing? And it's like, oh, that thing, that's a, it takes this time before it responds, right? And so I could fill that time up by having the Furby make a bunch of farting noises. Hey, Furby, how do you pronounce this name? You pronounce it, but I make myself laugh. All right, anyway, we need to get that op amp out of there so we can do a little bit of repair. And then we can probably throw the entire RP2040 onto the actual thing, because we've done the tests to see whether or not the current is there from the different controls. I would like to make a tester, though, make a more extensive tester that'll tell us what all the switches and knob states are. So to begin, and again, this is part of electronics design. Is the way that we do things now is a little bit different than it used to be. Circuit boards are so cheap. If you keep them below 100 by 100 millimeters, at least for Seed Studio. This one is 109 millimeters, and I kind of made that mistake. I should not have based it on the size, the maximum size of a modular rack PCB. I should have made it more narrow. It should have been 100 millimeters. Then these would have been significantly cheaper. Unfortunately, I ate crow on that one and ended up ordering a bunch of boards. But the power connector's upside down, and 2 of the pins are swapped down here. So now we reap what we sow, and we figure out how to get this board 100% working, and then we figure out how to get the other board 100% working. But bother, didn't you identify the exact same problems in this one? Yes, I know, this one has the exact same problems. They're solved in the exact same way. Flip the connector around and do a little bit of bodge wiring. The point is, we do all that bodge wiring and we get our circuit working 100%. Because it's possible that there are other errors, other dumb errors that I left behind. When you do this, it is a force of the universe that if you do not check over these things, they will be a problem. It's just, that's how it is. It is in a quantum state until you check over on it. And if you don't check it over, it's going to default to broken. Oh yeah, we have, I mean, I got servos out my eyeballs. We got all kinds of parts we can put in that cursed Furby. I would like to take its skin off. Geez, things get weird when you start talking about Furbies, but I do want to take its the fur off and get into there and do some cool stuff. I refuse to believe that you make mistakes. The amount of experience that I have with electronics makes it so that it seems like I do things and never fuck up. And sometimes you have a long running fuck up, which is, I actually quoted Fadanon on the it's not going to go up until like I think after the weekend, but the VOD that I uploaded, he's sitting there like, I think you misunderstand. Obother isn't patient. He's just not willing to let go. Sometimes the mistakes are sort of a fluid thing. Sometimes they're a little bit more punctual. I don't know, punctuated. Yeah, mistakes are indeed how you learn as well. But eventually you do this stuff long enough, you stick with it. I am of a mind that intelligence is not something that is inherent. It is a stubbornness about getting the results you want. And so people give me a lot of credit for being smart. I don't agree. I wish I didn't get the black circuit boards for these because I can't see anything. My tweezers are on the other desk. One sec. I'm going to get my tweezers. We're going to use hot air to remove this because that way it'll come up clean and I can reuse it. Because we've got a trace on either side of this. So in order to do this repair, let's take a look here. In order to do this repair, this pin swap, we need to get to the underside of the board. Let me flip the board. There we go. And we need to swap these two pins. So those two pins, here's our chip, and we're swapping this and this. So what I'll need to do is get the chip off, and then I'll need to cut back here and up here. And then maybe I could scrape up this a little bit and cut probably over here. And it'll be a nice, simple repair. I'm a simple man. I see a Furby in the preview and I click. We were talking about needing to do something cursed with AI with this one. Oh God, that's a light. Sorry, I just bashed you guys into my light. That Furby sits atop the rack with all my equipment in it. And I would like to make the fart box. This thing used to play fart noises for channel points. I want to make that thing into the Furby and have it do a little fart dance when it farts. That'll be something we can get into in the near future. Yeah, that's a Nixie tube. It's a clock that my brother got me for the holidays, and I don't have the heart to power it up. It's just USB, but it's a 1-digit clock, so it is a little bit distracting. That's a nice fucking kitty right there. I actually watched that episode of Trailer Park Boys last night. So, let us retrieve this chip. Let us get it out of here. All I need to do is tweezers. I should probably have long tweezers so I don't have to get my doughy hands too close to the heat, but we can just do this one off the cuff. So, heating up, I have the same hot air station that Louis Rossmann used to use. It was sent by members of my Discord raising money. That's the original intent of the Discord many, many years ago, was to raise money in order to get me a 3D printer because I hated 3D printers. I generally don't hate them, is about as much positivity as I can put into describing 3D printers at this point. I have been very involved. I promised chat that I would get very involved with 3D printers, and I have. I have a very well-functioning PETG printer that does structural stuff. It'll print out things that hold other things together. We'll have to do the Furby thing soon if that's going to get me viewers. I'm desperate for viewers right now because my primary breadwinning project has been down now for probably 5 years, 4 years. It died around the pandemic. Actually, right before the pandemic, I think. No. It was 2 years into the pandemic, actually, because I uploaded that VOD. That VOD is on the VOD channel of the board actually dying. It was killed by a username that was too big to fit. And it has been decommissioned since then. I turned the old boards into a backdrop for my gaming desk so that I could masturbate in peace. But we've been working on the new version of it, and it's been extensive. There's been a lot of engineering going into it because I wanted to get everything right. The other one was built kind of out of spare parts. This one is being built still out of spare parts, but they're getting a much better treatment. So it'll look fancy. There's hair in my eyes. I can't see anything. I really need to get to the barber. Like I said, I had kind of an executive function meltdown over the weekend. Always slide with the solder braid. Don't lift it directly. That's supposed to be there? What is that? That don't look like it's supposed to be there. Hold on, let's check. Oh, that's supposed to be there. Okay. All right, fancy stuff coming on. Usually I'd use a scalpel, but I have a tool specifically for this. I had leftover eggplant parmesan last night, or for lunch, so I'm spaghetti sauce irpy right now. This is a tile cutter. This is for cutting tiles that you would use to print stuff. And what I do with this specifically is use the V groove that it has. It has this wonderful V groove that I can use to cut traces. Alternatively, I can get a sharp knife, a scalpel blade that I have, and just do, you know, scrape and cut out these traces. We are on a black solder mask. It is impossible to see what I'm doing without a reflection, and our work is very small. So what I need to do is put a scrape on the front and the back of this trace right here. There's not a lot of copper there, so I need to just do it very carefully. Just double down. I think this might be too small for that tool. Let me use the knife just because it's a little bit more precise. That thing is for larger circuits. So where's my knife? My knife is over here. Should still be pretty sharp. I was using it to shovel graphite into parts for the RC car. All right, let's see here. So we need to cut this one too. And usually that would mean 2 lines. So I'll do this, and then right in front of it, and then scrape the difference. I need to get closer. Scrape the difference here, just in my previous trough. You can still see there's a trace there. It's like cutting it on both ends is effective. There we go. I think that might have severed it. Okay, so let's check that over. Let's get the multimeter out here. And put it to ohms, not the beep setting. The beep setting can lie to you. The beep setting has like a threshold where it beeps, whereas the ohm settings will never lie to you, and it'll tell you exactly what's going on here, because we are interested in conductivity. We're not interested in making a beep noise when there is a connection. It's not the same thing. And if you do it this way, you can actually see when you're viewing through a resistor and stuff. There's more information to be had. So this goes from here to C13. Or no, wait, this one goes to ground. Hold on. Which part is ground? Well, any of these vias are going to be ground. So no connection to ground. Correct. This one goes to C13. Oh, wait, no. That one goes to... hold on. 100 kiloohms, huh? Looks like there's 100 kiloohms sitting on ground over here. So yeah, this one is still connected to ground. Still connected to... Oh, wait, no, I corrected that one. Hold on a sec. I corrected that one. So yeah, this one goes over to C13. Does it really go through? It should go... Oh, the other side of C13. There we go. This one goes yoink. And these are actually reversed from where they should be, because I corrected it already in the design. So yeah, this one gets a big old cut right here, and then we figure out how to get ground to here, and then this to here. That's going to be a little bit more complicated than I thought. So I just need to cut that trace out. Do a little slash right here. We'll do one all the way up here. And then split the difference. Scrape it out. If I had to do this to every single board, I'd probably get a Dremel, but the bodge repair is a little bit more involved. Now, if you do a Dremel and you set up a little jig so that you do it the same every time, it'll give you a little bit more precision from the Dremel. Let me flip this around and scrape it from the other side. I'll make a pad right by C13. There we go. Okay, so that is definitely severed. Now I need a pad right here. Come on. A little scrapey, just to reveal the metal. I could go from here over to there, but I'll just go from this pad right here. I don't have a good record of the exact design, too, so looking at my computer doesn't help. Lurk. The accursed lurkers. See, if I was a little bit more accurate, I probably wouldn't have undone those 3 areas right there. So this is ground in proximity to this, so I've got to be a little bit more careful when I put it back together. This could probably become a solder blob, and if I use a coated thing. Well, let's do solder blob from here. I got that pad right there. These 2 I'll just meet up with solder blob when the chip goes back in. So that'll be that one. The other one, though, it needs a little bodge wire. I guess magnet wire is probably going to be the best one because it'll be the least intrusive. That's what I keep these little spools of these motor spindles around for, is because they're nice little magnet wire dispensers. Magnet wire is just has like a shellac coating on it. It's harder to work with, but it's also tiny. So if I'm doing small signal like this, I can just get away with it, and I'll have a partially shielded cable in the path. Problem is, I don't really have a good way of undoing the shellac on the wire. The best thing that I came up with was to scrape it with the iron. See if I can't get a tin going on that. I just see a small exposed area at the end of this wire. I'll see if that takes on solder. Where's my solder? There it is. Sometimes I scrape it horizontally with a knife. This stuff is so small that I don't think I'm going to get away with that. Oh, I need to clean the tip a little bit. Let's see what that looks like. That's a little better of a field to work with. Nice little blob going there. Find the end of my wire. Oh, okay. Let's go ahead and not melt everything in this thing's path, huh? Including my oscilloscope. Let's put that way over there. Okay, you guys come back over here. Not giving myself proper room to work. It's very important. So is that actually taking on a tin, or is that just me? Or did that break off? Well, it seems like it broke off. Magnet wire is such a pain in the butt. One way to do it I've found is microfiles. I just rub it with the microfile in order to remove that shellac material. Let me change tips to the smaller tip and we'll see this thing going back in. So I think we're going to work probably this size. This is where I'm most comfortable. Yeah, doing this bodge job on every single one is not going to be the best use of my time. What's up, Tater? Oops. There we go. So, I need, for this thing to solder to there, let's put the chip in place, because that's going to be kind of the first step anyway. So this is an SO8 chip. It's a nice, easy to solder size. Finish the memory board. Nice. Very nice, very nice. Pin 1 is on the left. It's not really well marked. Yeah, you were doing the layout on that, right? I meant to catch some of that, but I didn't end up catching it. Everybody here should check out the stream announcements section, because people update with the streams that they're running, and it would be cool to see some of y'all do you think. I saw the link. I did not, again, complete executive function meltdown over the weekend. I had a nothing weekend. I've been keeping up with the uploads that I'm doing for my channel, and that's about it. Did the layout, finished the board, sent it to JLPCB. Nice. Nice, 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 nice. That's good work. What is the memory board for? I forget what it's for. What is it for again? I mean, your whole theme is arcade cabinet, so I'm going to guess that it's for an arcade cabinet. It's an expensive... Oh, because is it massive? It's funny, VIAs are completely free now, but the size of the board makes everything. These are only 10 millimeters off 100, and that made the price go from probably $10 for 2 orders to $70. Which, considering that PCBs used to be like $50 for only a couple, still a nice price, but I could have made it cheaper. It would have been a big redesign for me to do it, because there's a lot of stuff that kind of gets close to the edges. The RAM board for a robot that your dad designed in the mid-70s? What? Oh, that sounds really cool. We should do continuity tests before we move on, just in case I cocked something up. Let's just check. Continuity tests before we move on, before I start getting the bodge wire done. That would be from here to ground, still disconnected. From here to this part of C13, still disconnected. C13 over here, connected, not over there. And if I go from here to ground, we have not connected it yet. Okay. So now I'm going to put down a solder blob that will short this pin to ground, as it should be. I guess I could put a little piece of wire on that if I felt like it, but I think solder is going to make up the difference here. So I'm throwing solder down on all these parts. And then I'm going to bridge these two. I don't think that did that. It didn't. If push comes to shove, if the solder's cooperating too much, I can put down a piece of wire, which I guess I'll have to do. So I'll get a piece of unshielded wire wrap wire. Actually, I could get a strand out of the solder braid. Can I actually do that? I think these are all welded together. Yeah, they are. A 6-layer board. Damn. Yeah, those are rough, aren't they? Do you have any blind vias? The dreaded blind via? Next piece is going to be the terminal board. Are you going to physically make that? 3D printing is like the printed PCB of the physical world. It's nice to have something that can just poop out what you need. I need the smallest piece of metal just between these two right here. So I'm going to try to extract one from something. Like a stranded wire would be perfect for this. Is there one that's cut? Yep, there's one right here. How does that work? Just find a piece of stranded wire on the desk that's pointless. Might just use the whole wire. How big would that be? Oh, that's going to be huge. I might use this for the whole repair. I'll just sort of glue these two together and then cut the excess. Just coil it up and put it over to its next destination here. Yeah, there we go. We use the whole wire. That's more wire for your wire. Oh, I almost cut my solder with waving my knife around. Just wave the knife around, doesn't even matter. All right, so I kind of want to soak that with a bit of solder, but the problem is, once I do that, the surface tension of the solder is going to pull all my wire up. Are they like 1970s PCBs? They're like kind of a little bit see-through. Or PCBs are translucent. I don't think that's soldered down to the ground. Now that it is, my whole iron wants to take it away. There, I think that's grounded. Let's test. S100. Oh, those things. Those are the ones that plug into a big rack, right? That everybody used to use for everything. Can you believe people would just plug prototyping boards into their computers? Like the ISA slot? You just plug a prototyping board with a bunch of soldered components. It's connecting to both. Damn it. This is why we test. This is what the multimeter's doing here. You can see all the way up in that corner. It says 0.3. It's not supposed to be connected to that at all. So that was a mess up. We effed up. Now you done fucked up. You have fucked up now. My iron on? Yeah, it should be. My iron. Now this gets plus minus 12 volts, so we absolutely cannot connect to that pin. That is not an option. I could do a little bit of scraping maybe to isolate it. I just can't see anything. I can't see where my trace goes. I should probably cut it away from there. I was just going to do a nice little elegant swoop with a wire, but it doesn't look like it because I uncovered a little bit over here and there's a ground pad right there. I'm going to have to use something with a shield on it. Never got how people built stuff out of those big backplane connectors. It was way too hardcore for me. All right, a little scrapey. Hopefully that means it's not connected now. But we have to test to be sure. See how long this repair is taking me. I'm not doing it for 20 boards. There we go, 1.5 M. All right, so now I need to solder to that, or I could solder to the outside of this thing. I think I'm going to do all the way over, because then I can use a shielded wire to do it. So I'll use a wire with a, I mean, not a great shield, but it is a shield. Instead of using that magnet wire that's like impossible to work with, I can just take a little bit of this stuff. Gimme. There you go. 50 pins per side. Each pin has a connection to the larger bus. That's still crazy. It's still madness. Maybe it's easy for you. I learned it from watching you. Also, what's up, Dins? He's probably gone by now. He probably left a comment and then ran. Oh, he's doing soldering. Fuck that, I'm out. Oh, melting the jacket there. I gotta be careful with this stuff. This stuff is harder to work with. I need a special pair of tweezers for them. Like, I need heated tweezers. That would be super awesome to have. Where did my wire cutter go? I think I put it away. I put it back in the drawer. I rage quit because you didn't use the whole wire. I'm sorry. that. Oh, that didn't, what the heck? There you go. Gonna do the big obvious repair here, and I'll bend this around a thing, a tool. Dang it. Why are you fighting me? Let's do it like that. And then I need a bending form. So I'll use my little hook here. Ugh. Oh, I don't like that already. Where is everything? Okay, this goes over here. And then up to the pin. I'm making it a big obvious repair. And then cut that up here. Now this is where things get sloppy with this method because of this wire wrap wire. I don't have a good way to strip that end, and I don't want to put any pressure on the wire because it'll undo all the bending that I just did. And I basically just want a nice clean tip on the end. So I could go in there and pinch it to within an inch of its life. I don't have like a pair of tweezer blades that do that job. I would love a pair of just heated wire tweezers that were small enough to do this, because then this technique would be much more elegant. Although then I'd have to wield hot tweezers, so I'd probably burn myself a lot. Actually, we're going to use that in just a second. So the best thing, I could try to roll it on the blade and get the jacket to come off that way, but that typically would cut the wire in the middle. I don't have that much feel control of this blade. One thing that I can do, and it looks terrible, is just melt the end with the soldering iron. So I can just take this and I can go boop and then get under it, and then that sort of melts away a bit of it, and then the rest will come off with tweezers. Usually that looks really bad. Everybody's got their little techniques for this kind of stuff. This one's mine. It's not that great. It'd be much easier if I had something that could just put just a little hot wire right next to that conductor. If I had solder to it, it'll back the jacket off a little bit because of the heat. These really aren't meant to be heated at all. They're meant for wire wrapping, which is where you wrap the wire around a post. Where do they come up with the terminology for this kind of thing? Now, see, now there's way too much wire exposed and sloppy. It looks gross. One day I'll figure out a better technique. One of the directors at my old work was retiring and or moving on to other stuff, and they wanted me to build a sort of like puzzle device because of all the IED work that he did. And I ended up making it using these techniques, and it was not the best looking circuit board that I've ever put together. It was really sloppy and gross looking. It was pretty bad. That's the award that you hide. You don't let other people see that one. Yeah, I got an award from them. Glances at desk drawer. All right, so now we check to see if the right stuff is connected. That was a little bit weird. That was a bit of a weird one. I'd rather use that magnet wire because then I could just run it flat on everything, and that would have been a little bit more elegant. But a bodge wire is a bodge wire. This is like when you're on a road rally and your tire pops, you want to get a white wall tire, just one, or something where you can put the text outwards so that it's known that you have different tires on the car. You eat the shame. You eat it. Delicious shame. Okay, let's check here. So we are going from this pin, obviously, to this pin. It'll be fine. That'll be 0.3 to whatever. We go to ground. Nothing. Good. Now we go to this pin to ground. Continuity. And go here. And it's nothing. 1 mega ohm. Okay, so we are ready to fire this thing back up and to see whether or not it lets out a bleeding, cursing howl of audio. Let's get the knife out of the way so I don't accidentally puncture myself or any of you in the splash zone. A little bit of a sloppy repair, but we're willing to live with that. Does it release audio or magic smoke? We got it to release audio before, so it should do it again by all means. We had to reverse the power socket. Luckily that was symmetrical, so it just flips over. And then do this repair here, because the op amp was the opposite way that it should have been. So now on the output line, which is going to go, this was supposed to be an input, whereas I don't have anything set up on the output. Okay, we'll set this up on the output. This one will be out. Yeah, audio out comes from here. And then we need the RP2040. I'm going to take it off of the perforated prototyping board. Should and will. Listen here, you little shit. We had this working yesterday, or last stream, which was like a week ago. Sorry about Tuesday. We'll do Tuesday next week. I promise. All right, so here we're connected. And then the power supply is not set up yet. Hold on. Unplug that. Come over here. Dinsdale, you need to replace wish with will. I will my father to come back home. I actually got that fortune. I forget where it was. It wasn't from a fortune cookie, I don't think. It was replace wish with will. I'm like, really? This is like the easiest one to debunk. All right, multimeter goes away for now, unless we have some horrible sparking issue. This can go off, because we're not doing any hot air soldering now. Goes back there like this, and then I twist this so that the cable's out of the way. And then we take, power's plugged in, external power is not. Turn this on, nobody's plugged in right now. Nice, clean, easy setup. You keep it simple, because in this case, stuff can go wrong very quickly and you'll want to be able to act quickly. And if you've got too much clutter and you're flailing around trying to put out a fire, you'll be in trouble. All right, hold on. I got to put the soldering iron wire away. The cable. There we go. And that can just park right there for quick deployment, but keeping it out of the way. Okay, so output is off on the Agilent, but in order to put power out, you actually have to turn power on. So now power's flowing out and I can configure this thing. It's not the best design, but I mean, this thing is from like the early 90s, so 12 volts, minus 12 volts. There we go. Hagiwo insists, the original designer of the VCO that we're building, insists on using 5 volts. And I don't like to do that. I like to use the plus minus 12s because we've got the op amps running off of those as well. So while we have plus minus 12, we just put an LM1117 on that plus 12 volts and we turn it into 5. So that's where we get our 5. Well, actually, we don't even turn it into 5. We don't do anything with 5 volts on this board. This is a 3.3 volt device. So we have an LM1117, but the 3.3 volt flavored LM1117. When I plug this in, we should, by all means, see a sine wave appear on the scope. And I guess you guys can get scope view. We don't really extensively need the scope right now, but we'll eventually make a different program that'll serial print all of the stuff that's happening on the board. But if I plug this in, we should see nothing. Well, we saw a sine wave with the previous one. Why no sine wave now? These don't actually do anything. RP2040, not on fire. It appears to be powered on. What if I hit reset? Which one's reset? R. Interesting. Oh, this is going into channel 2. Channel 2 is not active. That's the problem. Well, now channel 2 is active and nothing's happening. We should be seeing a nice big audio signal. Okay. Just check for any spurious signals. This is loose. Check number 2, is power actually... Yeah, power is actually getting to it. And we've got on the stripe line, where the stripe is supposed to be, we have minus. That's minus, yes. Okay. So we should be getting good power to everybody here. So let's check to see what's going on. So if we plug that in, that gives us a ground. I can get this over like this, and we can start poking it. Just kind of get a little bit of a grip on it there. Then I can poke, see what's going on. Nothing's doing there. That one's ground. That one is... We're on the right chip, right? That one should be 12 volts. Oh yeah, that's 12 volts because the yellow is on a different scale. Yeah, see that's... Okay, so positive 12 volts here, and then negative 12 here. That ain't looking like negative 12. There it is. Negative 12 volts is drawing 0.1 amp. For some reason on the chip I'm getting a weird result. Did you short to ground? Okay, let me turn off the supply and then scrape it with the probe. Turn it back on. Still no audio out. Well, that doesn't look right, huh? That's ground. This should be negative 12. When I poke it, it goes to negative 12. Maybe there's just oxidation on the outside of the... Yeah, there we go. Whoa, and all of a sudden, wait a minute. Okay, yeah, so something's messed up with the negative 12 line. It's hot. It should have a little heat to it, not a lot, but that's not abnormal, although getting as warm as it is, maybe that was an indicator. Let's check what's going on with the solder there. I may have shorted ground to negative 12. I think that's probably what's going on. Luckily, it didn't kill anything. That's always nice. That or it's just straight up not connected properly. But if we... Okay, let's not melt all of our power cables. Get our bodge job out of the way. I should have gone under and over. Where's my tweezers? Tweezers. Tweezers. Yeah, see, I melted the jacket right there. Stupid, stupid, stupid. I am indeed live on YouTube. That's how Wonky Robot is communicating with us. Hence the YouTube signal by their name, symbol by their name. Pretty neat. I'm going to move the bodge wire. We're going to go under C whatever. That way I have room to look at stuff like this. YouTube sends its regards. I'm not big enough to have like rivalries between YouTube and Twitch. I'm not cool enough yet. I say yet, but I don't think I'm ever going to be. I don't think I'm ever going to raise that amount of those numbers, that amount of people. I don't know how Oo does it. I think maybe just because he's got a North America crowd. He's got those NA viewers during the evenings. I do not know how he does it. Maybe I need to blow stuff up in order to get people in here. When Burn the Subs gets active again, there will be hopefully a little bit of reception of that. I tried to get published in Hackaday with that because I used to write for them, but they frickin' ignored me. Those bastards. It was just like, nah, you're not on our forums, so we don't like you. It's a shame too, because Burn the Subs was really fun. But we got a lot of good ideas for it, and it's going to go back up and hopefully make me some numbers again. At Oh Bother on YouTube. That's right. I do have my main channel. It's actually Work Verb Design, just because that's what I came up with the XKCD password generator when I won the Reddit Millionaire Makers contest that one time. My account got hacked. Maybe it's because you refer to them as you bastards. Have you ever been on Twitch, Dins? have you ever maybe like watched a stream? I'm to be considered nice. Also, I'm from Philly. If I'm not calling you guys like jagoffs or bastards, it means I don't like you. Those are the laws around here. I know some of the international types don't really take too kindly to it, but especially the Brits. Well, actually, I think Flatulent Gonad, well, he's not entire, he's like northern. But yeah, like if I'm not calling you guys bastards, it means I'm being cautious around you, which is not a good sign. We bastards, math. Oh, speak of the devil. Math checks out. No, I just think the last... Oh, there's still graphite on these tweezers. No wonder I'm slipping. I don't know. The last proclaimed Brit in here was way overly sensitive to the kinds of camaraderie that I bring to the table. All right. So this is a slightly rerouted bodge job. Our goal right now is just to get the board working. There's no other goal. I'm not ordering new boards at this point in time. I may eventually, but this is the VCO. This is the single channel VCO. I didn't stream Tuesday because I had a complete executive function breakdown. I've still been uploading videos, but I just like, it was a bad scene. But anyway, I'm back on my regular schedule, and we are getting this VCO working. I flipped... If you look at the design, the original design, where's my mouse? If you look at the original design, what we have are op amps, operational amplifiers, comparators. Well, actually, comparator is different, isn't it? Anyway, they're comparing these two, right? And then they amplify it depending on the circuit layout. If you do feedback, they're basically just a math engine designed to make you do algebra until your eyes bleed. But this is an inverting, well, this is a complicated one. This over here is an inverting amplifier. But what we have is a Sallen-Key low-pass filter that turns PWM into audio waves. It does that through the magic of math. Who the hell knows how that thing works? But the key part of it is that the plus and the minus are swapped between these two. And I did not know that. I thought that they were in their normal configuration. So I screwed this up and those two pins needed to be swapped. And it's not in a very inviting or pleasant area of the design. It is in fact in the thick of things, and it's down here that the two had to be swapped. Now, this one, you know, successfully did it. I did it on the other one too, but I'm not about to go and order circuit boards. So instead, we are bodging this repair. Two mistakes so far. One was the power plug was flipped 180 degrees, and so negative was going into the wrong place. That was just a dumb error on my part, and oh, it looks like I didn't actually correct the in-between lines. We don't need them. So this was actually corrected by just soldering it in upside down. So I didn't need to order new boards for that. But then this one is only repaired by actually physically repairing it and rerouting the two traces. And so I haven't ordered boards for this one. We're still looking to see if there are other errors in the board. So we need to get that working before anything else. Nothing wrong with hairy bodge wires. I'm not going to bodge every single one of these PCBs. That's an amazing amount of torture. It's more worth my $70 just to order new ones. But I want to make sure that we are, you know, cracking down on the appropriate errors. So yeah, let's get this thing back up and running, and I think now it'll work. Oh wait, no, before we even do that, that's irresponsible of me. I need to get the multimeter in here, hook it up to the multimeter, and see whether or not we get proper continuity on stuff. The multimeter's like, I knew you'd be back. They always come back. If I ever need soft jaws, yeah. That's a good point, actually. They're a good size for that. So, -12 and ground. 5K. That's a decent amount. I don't know what we'd see through the, yeah, that's a charging capacitor. So if I flip them around, I might get negative resistance. We're charging up the capacitors by doing this. And then continuity from ground to ground. And then continuity from signal to ground. Okay. So continuity from ground to -12. And then continuity from -12 to -12. Okay. All right, I think we're in business. Man, so going out, I've been uploading all of those wheel streams where I'm struggling with code, and I finally got to the stream where I got it kind of partially working, and it makes me want to do the 10K challenge with my summer car. Just hang out with the wheel and drive around the road. I don't know if I've got it in me. That'd be, how many streams did it take you to do? You were doing long ones too. I know, more my summer car content, but it would just be me going on the highway. Can I get 10K by just practicing the rally? I think I probably can. Do you have to go all the way around? 10,000 kilometers is a friggin' long way. Yeah, it's crazy. What did you use to get the meter? Was there a file that eventually stores that value? He had like a meter at the bottom that would say how far he went. You can go anywhere as long as it's 10,000. I might have to go back and forth on the rally course and just learn it. You do rally course and then do it backwards, just over and over. Oh, you were actually entering it. Oh, I see. Okay. That's, I wonder if you can find that variable in memory somewhere. You'd have to use Cheat Engine, I guess, in order to get in there, though. I don't want to use Cheat Engine. But it would make a cool little on-screen display, though. All right, so we are ready to give this power and see whether or not we get an audio wave. And we do. Trigger, channel 2. Get rid of this menu. And then you guys get treated to the scope. Oop. Yeah, you'd have to use Cheat Engine to get into the memory, which is kind of annoying. This looks like it's clipping. What's going on here? Oh, look at that. It's almost like it needs like another filter on it. Look at how woobly that is. The Predator view. It's a Group Gets thermal webcam. If I put like a capacitor on that, like a small one, I wonder if that would smooth that out into a straight line. Although you probably can't even hear that. And it probably has to do with the modulation that's going on, because we just chose one of the modulations and put it into the Raspberry Pi. But we are outputting a wave now. We have a waveform coming out of our VCO. I can't control that with anything because we're not doing it the same way that everything else is doing it, right? We just put code directly into the thing. But this allows us to now proceed with a test program that'll tell us if all of our physical controls work, and then we know that the hardware is 100% squared away. It was me. I was the predator all along. Okay, you just wander into a school and start saying that. Jeez. We're an educational stream. We're basically a grade school. No, we're not. No, we're not. This content is not for kids. If you're under the age of that you're allowed on Twitch and you're watching this, fuck off. You jerks. Semi-cromulent wobulations. I don't think audibly we'll notice this. Oops. Notice this. But it's kind of doing like a vibrato, like a falsetto. No, it's like a vibrato. Ooh. It's sort of like holding the note by wobbling around it. So, that works. Ooh, like that happened. All right, so let's make a test program. I'm too tired to code today. I don't know if we need like another filter on this, and if we do, I could put that into the design, but it's aliasing, yeah. It's not quite hitting the right note, but it is mostly hitting the right note. So I've got a bunch of Arduino, and here's our test program. I was working on splitting up these polynomials. This is a little bit more math work than I wanted to do, but this is part of it making the wavetable. Right now, all we're doing is what are we doing? We have PWM wrap. I have the, oh wait, this isn't the right one. This isn't the right program. Where's the program that we actually sent in? There's a program that has nothing to it except for the wobulation code. I believe is this one. Well, this one says rewrite. No, this has too many functions. Was our test program really that extensive? This one is the test program, and what I should be running on this one is a serial print test. PWM finishes, it resets the frequency, and it uses mod2 wavetable of K. That's frequency table at octave scale. I think we're going through all the motions, and I've locked it into one. That's all the PWM setup. That's all the pin setup. And then in our loop, mod is 1, oscillation frequency is 1.25. For int of I, Jesus Christ, this is 256 mod, wavetable times mod. For int, yeah, so we're doing whatever the method here is with multiple different steps in it. And it's just another way that it creates that sine wave. We've locked it into making this specific one. And then down here is where I'm working on just stuff that's not relevant to what we're doing right now. So I guess I can comment this out for now. I don't want to work on algebra just yet. We need to like figure out, I need to look stuff up and figure out where this stuff is derived from. Like where did this sine wave equation come from? And then maybe I can isolate out some polynomials and make it sort of make a little bit more sense as everything goes through. This is the VCO, yes. This is creating a high frequency PWM that then I guess creates the wave that we see on the scope right now, which is here. I need to put this to a button. Oh, do I know the scope here? No, I don't. Okay. There's the scope. So we have this wave form, and it looks like this. A little bit wobulaty. Doing a little wobulation there. But it does look like a nice clean sine if you back out far enough. How warm is this? That's not warm at all. It looks like it's warm. It's actually fairly cool in this shop right now. So, but yeah, what I want to do is I want to do a bunch of serial prints. That's one of the easier ways to troubleshoot your 130 kilohertz PWM frequency noise. Yeah, but I mean, like, what to what end? The frequency is being measured on channel 3. I can just swap this over real quick and we can see what the frequency is. 600 hertz. 633 hertz. Which this frequency said 1.25. Somehow that comes out as 633 hertz. And then I guess if I... Well, first of all, I need to change the trigger to channel 3. And then we can get rid of that now that it's nice and stable. I said, yeah, 633 hertz. We'll have to do math on that later, but if I zoom way in, well, give me this frequency. Come on, you can do it. I mean, I'm sure you guys could probably visually put that together. They turn off the frequencies or the channels that we're not using. There we go. About an octave and a bit above middle C. Huh. 100 picofarad? Wait, what are you making with a 200 PS? Because I might just have the value that you're looking for. So 250, 1 octave up is double. Huh. Yeah, so what Ben Gizmo is suggesting is that we alter the value of part of our Salin key in order to lower the frequency. So he wants to take it down half by putting, instead of a 39, where's the 39? That's, oh, did we follow a different? No, I used 100 pico in both of these. I didn't use 39. Unless I got that value from somewhere else. Yeah, I don't think I used 39 in it. I think we used 100 picos. Should be 100p or more. 39K to 100. The first one. So this one right here. I don't have a lot of 100Ks. Actually, I think I have a bin full of them. We can try that. That's an easy one to do. Oh, both? Let's just do. Well, let's do that real quick and see what effect it has. So power down, and then I need to find where they are, and we'll just throw a couple 100Ks in there. I think it's these over here, so it's going to be kind of tough to get to, but that's a shame. Those 39 were kind of a fun value. Everything's 100Ks. Lowers the cutoff to keep audio frequencies, but loses more of the switching noise. All right, we'll give it a try. Let's see. These are these are 0603s, so I need 0603 resistor. Problem is, I think I have enough. I think I bought a bunch of 100Ks to replace. Boop, 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 100 ohms. Go down to a 100K. Yeah, I've got plenty. Okay, good. I was worried about that. The synthesizers use a lot of 100 kilo ohms. Now, I'm going to try it because we got things on the scope and it's fun to show affecting the physical world. Rearranging code is boring and it's something that I should be doing in the background, but we will attack that code. What we're going to do is put serial prints into it so that I have something that'll tell me what all the pin inputs are reading. So the potentiometers, the CD inputs, and the switches and stuff. And so I need like a little display that does everything, but this is you know, this is also work. This is also things we need to be doing. So the ones that I need to replace are Let me look at the schematic. That'll be easier. 11 and 12. Oops. 11 and 12. Seven two D. Oh, A and B. B is A is 1 2 3. I feel like I did this edit to the wrong. Well, that's the wrong board. We're looking at RP2040 VCO. Which one of y'all is the amplifier and which one of y'all is the Salin key filter? I think I just flipped the amplifier, not the Salin key filter. Wait a minute, what does the amp look like? Between 6 and 7. I think I flipped the wrong one. No, because the schematic program told me to edit it. It's just weird that like 5, 6, and 7's over here. 6 and 7. And then which one was flipped? I thought the Salin key one was flipped. I guess maybe this one was the one that was flipped. Yeah. So are the other ones in this orientation? No, they have negative on top. This one is positive on top. So why did it tell me to edit those 3 pins if it was the other side? I'm confused. I'm confused. I think maybe they were both flipped and this one was in the wrong. Did that one have positive and then the other one went to ground? That must be it. Weird. It's just something that's like just confusing me right now. Oops, it's all the way over here. Because it was pins 2 and 3 that I flipped. Physically, I flipped those 2, and then everything started working again. And I don't remember when I did this last stream. I can pull up a clip of me doing it right now. And I would probably be working on this one and not the other one. I guess this is the one that I got wrong. Strange. It's very strange. Okay, anyway. It works now, so whatever. But that's just really weird. 11 and 12. R11 and 12. So that's going to be in this area up here. And they're right there. They're right there. They're easy to get to. And I can put on the big soldering iron tip, and I can pluck them out without burning myself. Once more, thermal imaging saves my bacon. I gotta not put my wrist down on these resistors that I put on the work surface. Okay, so 11 and 12. See how they're 393. Oh, and the iron has to be on, actually on. There it goes. I'm going to keep these nearby because I don't fully trust Ben Gizmo. Just in case we got to put them back in. I say it like Ben Gizmo, but it's Ben Gizmo, isn't it? Nobody should trust me. It's just good policy. All right, so 100Ks. It's like, won't this limit the amount of current on the... Where is C6? C6 might actually be in there, but not... C6 is fully missing. What the hell? Why is C6 gone? Okay, I'm gonna have to find C6 at some point. Let me just do this first. Look, I'm all thumbs right now. All thumbs, standing by. Okay, that's one. Do the other one. Soldering them both at once is not that responsible, but yeah, I don't know, maybe it was never installed. It's possible that I just missed it, because it looks like one pad is soldered and the other one isn't. C6 is on U5. Let's see. This is a resistor. I brought this from home. What happened down here? C12 is also walking away. I moved C12 with the giant soldering iron by accident. Please sit down. There we go. We should have worked on the yellow board first. This would have looked cooler. All right, let's get you back. And see, is there anything on C6? No, it was never installed. Okay, so C6 needs to be installed. Ruin a working PCB now. C6. That's just a high frequency cutoff for one of our inputs, but we still should probably do the business of putting C6 in there. So I need to look at my original schematic and figure out what value goes there. So that is here. Dang it. There. 470 pico. Get my capacitor book. And find 470p. Of which I've used a lot. This goes back. I think I just straight up forgot to put this one in. Missed it. Missed it in the fray. Oops, wrong one. This one. Go. So now we grab this from over here. Move it into position. I hate it when the tweezers get sticky. They pick up flux, and then the flux causes stuff to gum up against the tweezer arm. It's very annoying. At least I could have done the due diligence of putting a part in and not soldering it, but instead I just didn't even put the part in. Yeah, we always do paint schematics. Always, always. The paint schematic rules all. My engineering notebook. And that means that I have something that can go in the file. In the folder, rather, with all the other files for this project. All right, so there's C6. It wasn't doing anything for us then, but it won't do anything for us in the future, and it doesn't hurt to have in there. Now I can get this thing hooked up to power, and we can see if we still have that wobulation on there. Keeping in mind our 100Ks are still right here. Move those to right there. And this turns off, plugs in, turns back on. That is much cleaner. Much, 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 not much cleaner. It's not much cleaner at all. Look at this. This is horrible. They are a bit less, yeah. It does look a little bit smoother on the outset. but it's still wobulating. I wonder what you do to cut that off fully. Anyway, whatever. Whatever. Notes for the future. We now need to check to see that all the physical stuff is working so that I know that my circuit board is fine. So we're going to set up something that will print out. We could do them individually or we could do them all at once. I don't know. Let's put together just a little test program for this. So, I mean, like a what do you call it? What was that thing called? It's one of the programs that you can run where you can take over the Arduino fully. That's basically I don't want to get blood clots. I want to move my legs around every now and then, but every time I do, my setup punishes me by unplugging the microphone. All right, so yeah, let's get just a little bit of basic Arduino stuff going here. So what we have is our test program, and what I'm going to do is I'm going to comment out any of the mess. So I've commented out my equation work down here where I'm trying to kind of sort things out. For table set, that's what's doing our sine wave output. We're going to keep that, and then you know, the octave scale set we're going to keep around, but we're not going to do much with this stuff. What we want to do is we want to set up a hardware testing mode. So what is this one? This would be like table mod. Oh wait, but those OSC frequency would be out of scope, wouldn't it? Oh, but it's not even used here. Mod is equal to 1, but that's multiplying by 1. And that's within this scope, so. No, I don't want a wireless mic. It's very specific. I'm very specific about the types of microphones that I like to use, and I don't want to be wirelessly transmitting data for my microphone. The reason being that I don't want to take you guys to the bathroom with me. It's a very deliberate unplugging from the mic that I have to do in order to take you know, my audio over to the bathroom. Okay, what are we doing? I'm trying to figure this out. I'm trying to think about what I need to be doing here. So we basically want to test all the ins and outs, and to do that, it would be better if my loop was much more simple earlier, which means I guess I can take all of this stuff out. OSC frequency isn't being used anywhere, is it? I think it's being overwritten for something else, but like nothing in the code is being highlighted for OSC frequency. None of it. Okay, well, I don't need that variable then. Wonder what that was doing there. What are these doing here? Oh, these are just running larger setup functions. So in table set runs, we come all the way down to table set, and it does 4 I is equal to that, to do a bunch of stuff. And that puts that populates wave-table. Okay, so this I'm taking to do wave. Do wave. Yeah, it looks like it's used in PWM wrap. Why didn't that highlight? I guess this one doesn't do that. Why did I think it would? All right, so there's do wave, which is just our basic wave function in there. Since this is just a test function, so there's that. So what we're doing here is we're just making this very simple. So test funcs for running our test functions. And we can comment that out on later code. So, well, let's do test prints. Test prints. So our test prints, I'll put them all the way down here. Void test prints, like that. And we need to make sure that we are starting up serial. So up here in setup, we'll put that at the bottom of setup. Where do we do big set pins, make huge F off table? Okay, so yeah, here's where we start serial for T shooting. Serial begin 11:5200. Serial print line start a nerd. So that's when we started the program. Don't need anything else there. Loop. So we'll do test LED and test prints. And then test LED down here. Probably should set that up on a timer. But we'll start off with our test prints. So we're basically print the states of all the inputs. And the output's just doing a sine wave. So now the question is, how do I sync up so that something that can update over and over again and it just displays like a page of the serial stuff? And I guess we could probably put it up to charts too. We could do a chart that shows it. Because I can have a block of data that just comes in or I could do a line of data and it'll just scroll down. I guess I'll do that. So serial prints, and then we actually need to read the analog inputs somewhere. So let's do read analog. So read analog. Do that one. So read analog should read in and log whatever the state of the analogs are immediately. So void read analog. And then we need to put, I guess, values from the reads into stuff. Octave select, mode select, CV in, panel LED, pot frequency, pot freak, and pot oct. So we're way down here. Pot freak and pot oct. And then we presumably would store that into a variable, right? Osc freak old mod int slice number. How are they? They're probably doing it very directly in the old code. They're probably doing it very directly. Analog. Search for analog. There's our analog read 26 times calibration, and that's ADC is equal to. But there should be another one too. Maps it to the frequency, I see. 26 and 29, that's mod parameter set. Mode is equal to 0, 1, 2, and 3, and that's directly 29 and 28 are applied to that. Adding them, adding them, adding them. 0 to 10, 23, and then a different range. 28 CV, 29 is potentiometer. Okay, so that's, I mean, that's, well, okay, so we'll treat those as separate at the moment. We need variables for these things, I suppose, because then we can split it out to do the calculation differently. So what I'll do is in read analog, we will have just a bunch of variables that go into it. And so those are going to be Oh, should there be ints or floats? What is ADC in this one? ADC is equal to bleh. Int. Int. Let's do octval. Oct analog value. No, oct value. The next one is freak value. Then we have, well, okay. Octave and frequency, are those on both on CVs? They're different though. What did they call it? What it do? Hunting for my stuff. It's just CV and pot. 28, 29, and then there's another CV and another pot, and I don't know if they're both. I guess that one might be the mod. Push switch digital read 6. Loop 1 modulation. Okay. This is weird code to figure out. So let's do like, we do CV1 and 2. What do we call it over here on the actual board? I want to call it the same thing. Just CV in. So P28 and P26. CV in. Oh, CV in and octave in. Okay, CV in, octave in. So octave value and then CV value, and then freak value. Octave CV frequency, and then there's the pot oct. So what am I calling that? Because that's another oct value. Oct value C int oct value P. Let's just declare these so they don't get random memory. Input variables. 4 inputs, and then we have the switches, which will be handled differently, but int switch, what is it? There's an octave switch, and then there's a mode select. Switch mode, and then int oct cell. We'll do lowercase s so I'm not confused. Switch octave equal to 0. So those two switches, and then we've got pots, the CVs, the button. The button will be handled differently. Yeah, we'll handle the button differently. I may want to use my bounce library on this. Bounce 2. Bounce on you, boy. All right, let's see here. So we're taking all that stuff and we're going to read it into those variables. And then I need another program, actually, and that's the switch handler. And that can eventually grow, but switch handler and then a button handler. I'm setting these all up as these little programs. Just stupid hiccups. Setting these up as these individual little programs because eventually I can expand on them, and it helps me to kind of like explain what the program's doing. Geez, these hiccups. Where did that come from? Heavy pasta sauce is where it came from. So what I'm going to do is I'm going to read my anals. Don't do that. We're going to analog read pot freak What was the number for? I don't remember. I don't remember how to use these things. So that would be freq value is equal to analog read of pot frequency. Oct val equal to, oh, it's oct val pot, oct value pot. And the frequency value is the frequency pot, but wouldn't there be a CV for frequency? I'm already confusing myself on the naming, the nomenclature that I brought to the table here. Pot oct. That's the, yeah, that's that one. And then, geez, I might as well just take away all this. Switch mode we're not doing here. Why is switch mode even? Oh, that's the, right, that's the value of the mode switch. And I guess I'll use, I could set it off with that, or I could do them both at the same time. I guess I'll just do both of them as the switch handler. Read analog, switch handler, and something to blink the LED. So, octval, control voltage, octval of potentiometer. So octval of control voltage is coming in to there you go. Let's just take this whole block and bring it down so we don't have to scroll back and forth. Down we go, down, 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 all the way to the basement. So octave select 1 and 2, those are the switches. Oh, and the button and the mode select. So that's all one big block that I'm gonna, damn it. I control Z'd my way away from getting the information that I needed. I gotta go back up and get the block again. So we're down here where we're actually doing stuff. I'm gonna put this whole thing in there, and then I'm gonna take my buttons out, which is that block, and they will be on the switch handler. The button won't be. The button probably gets its own thing, but now I just have all of my variables here, so I need to assign these properly. So CV input and octave input. Frequency value is the pot frequency. Octave value for the pot is pot octave. Octave value for the CV, possibly, no, it's octave in. Double check on the hardware. That doesn't really tell us anything, does it? A0 would be CV input, and that would be the potentiometer. Yeah, P26, right? P29 and P27 are the two pots. P27, P29. Pot frequency, oh, I named them. I named them. So pot frequency and then pot oct would be the octave value there. So yeah, this is correct. Octave value CV input, P26. CV value and then frequency value, I think we already got that. Yeah, frequency value we already got. And then wait a sec, I'm doubling up. So it should be the frequency from the potentiometer, and then the two CV inputs are the analog inputs that we have. That's that. So once we get those, then we can go and serial print stuff. So we read all of our analogs. And then we do print stuff. So serial print, and I guess we can start off with, which one am I reading twice? Pot frequency. That should be the other CV. Why is this so confusing? CV in is what I need. The other one is octave in. The terminology just switches constantly, so it gets kind of annoying and very confusing. I could probably work on making those a little bit more standardized. So we read all the analogs and we put them into there, and then we go down to the serial prints, and we serial print. I guess we'll do value wall, value wall. So this would be CV in. I don't think I need the equal to. I think it's maybe a semicolon will do that. CV in, and then we'll put the value down as serial print F. And then I want, oh God, what do I want for those serial prints in order to make it come in properly? It's an int, but it'll truncate all the zeros on it, which we're not printing binary values. So actually we could just do print. Serial print, and then we'll use the octave thingy. Wait, why am I doing it like that? That's wrong. I guess I'm just going to do basic prints. Yeah, we'll just do. So we need frequency value. Let me just get the list of things that I need to print. So CV in is going to be CV val. These are just ints. Then we'll take this again, and we'll actually follow it up with a wall like that. And the next one is going to be no, CV in 1, CV in 2. I probably should rename all this stuff so it's easier to follow, but LC, take that, bump it down, give it a little space to breathe. Because this way we can just throw everything on a chart and hopefully it'll come in block by block and we can see the things changing. It doesn't need to be the prettiest, and I don't need to use like, you know, carriage returns or anything like, you know, to clear the whole screen. Those are the CDNs. Print. Oh wait, no, I'm cutting and pasting. I'm cutting and pasting. This one would be oct pot octaval pot. Oh, forgot the P. And then we do the frequency pot. That would be freak val. Okay, so next we want to print the states of the switches. And those I will be putting directly in from the values here. So switch mode, switch octave, and then I guess button is one too. Serial.print wall mode I should probably put a space before the wall so that we get the value just out there without a wall right up against it. So mode and then SW mode print wall and then oct it's not clean, but it is readable. Or it's not very efficient, but it is readable. And then I need to do the button state. So for that, I actually need to, man, you back up. Yeah, did I miss something by doubling that up? CDN1 value, CDN2 value, octave pot, frequency pot, mode switch, octave switch. So I didn't actually, this is just doubled. Straight up doubled. I didn't miss like an analog input. And then let's see, switch mode and switch octave, and those will be handled by the switch handler that'll read their states and then punch a number in. So switch handler and button handler. Let's do the switch handler first. So digital read. Is it? Wait a minute. Digital read. Oct cell 1. I probably could do this by shifting values in, but it has a weird behavior in the main code. Let's see what that weird behavior is, and let's just make sure we duplicate it so that we get the right numbers for our modes and our switches. Where is my Arduino window? I have 10,000 of them open. Okay, there we go. This would be the original code here. Yeah, there's the original and then there's the rewrite. So what I'm looking for is the digital read. Oh, here they are. Octave switches 1, 3, and 0, depending on which one is flipped. So digital read of 0, digital read of 1, 4, and 3. I have to translate that. And the digital read is coming in as it's coming in as a 1 or a 0. So I mean, I really could like do like a byte mask and put it in directly into binary, but I guess this is doing multiple calls for reading the state of the switch. I probably should only do one and then pull them into like a UNT8T or something like that. And then I can see what the value of the UNT8T is. I can set the bits based on the states of the switches. I'm going to do that. Is there UNT4T? Can I do a UNT4T and use even less data? That's fine. It's fine. We don't need to do that. UNT8T. It's way too much space, but W1 is equal to, well, it's going to be equal to 0 to begin with. And UNT8 is equal to 0. We'll set them up inside of here. So then we do we'll do bit sets. And I got to look up bit set because I'm dumb. Bit set is just one of these nice little crutch things, right? Where you can, instead of having to dive into bit math, you can just say, I want to set this bit here directly, and it does the bit math for you. It's just one of those little nice things to have in Arduino. I don't know. I just don't like to be wasteful with that stuff. What is this? Micro PLC with IoT capabilities. What the heck? Go away. 161 euros? Arduino Opta Wi-Fi. Secure, easy-to-use micro PLC with industrial IoT applications. Designed in partnership with Finder, Learning Industrial, and Building Automation. Well, that's interesting. That's kind of a cool thing. They're not cheap. Portenta. Oh, welcome. Torsten. welcome to Philadelphia. Arduino speech recognition engine. What the heck? This is some crazy stuff. I can't believe there's a big industrial like PLC. It's kind of cool. All right, anyway, back to this stuff, and what we're looking at is oh yeah, arduino.cc. That's why I opened that page in the first place. I just got sidetracked so easily. Where is our reference? Is that in documentation? Why didn't the pop-up? Where's the pop-up? What? Weird. Where did you guys put the reference? God, Arduino reference. Did they reorganize their site? / reference. All right, whatever. Bit set. That's right, a 1. We don't want that. We want to write a bit. Float and double are not supported. You can blah, 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 blah. So we're going to do 0 and 1 to bit write. Bit write. SW1, bit 0. And then the last part is digital read. And then we're setting it to oct cell 1. Bit write. SW1 of 1. Digital read oct cell. It's all caps. Please don't correct that stuff, because you guys don't give me a chance to do that when you do that. And it's less real. Good afternoon from America's armpit. You went to Florida? So we bit write those two, and then I can do the same thing for the next one. So this would be the octave select switches, get stitches, and this would be mode select switches. And we do the same thing. Oh, wait. Like that. And we write in the first 2 bits of it, and that would be mode cell 1 and 2. Damn it. And select 1. Mode select 2. We don't need the button right now. I just thought Florida was the armpit. I guess we're talking about that little one next to Arkansas. I don't know. UNIT switch 1, switch 2, if. Now, how does this roll in? How does this roll in? This has weird logic to it. Florida is America's dong. I was going to mention that. I decided not to, but I suppose you beat me to it. What were those pins? Oh, I don't want to do that. Oh, hold on. Okay, so I'm going to look at these. Oh God, I'm hitting all these buttons and nothing's happening. There it goes. What happened? Something weird happened. Okay, there. Go back on that and let's take a look at the pins. So for pin-wise, what we have for these things... Wait, what's going on? Did I hit compile? What are you doing? Now, I guess I'm not plugged in, so... Mod was not detected in the scope. What? Oh, times 1. Why did it suddenly compile? Armpit, New Jersey. I mean, it makes sense. There's a lot of toxic waste in New Jersey. All right, save that quickly, and then we'll take a look at the pins, and I need to see what the behavior is when I flip the switches, so I can make them nice and clean. D9, D10, D4, D7, P0, 1, 6, 3, 4. Okay, so over here we have our pin assignments and what they do to oct switch the variable. Can I? There we go. I was like, can I grab this? What's going on? So if, remember, these are input pull-ups. So they read a 1 when they are not selected. When they're selected, they read a 0. So we are taking our switch, and this one is between, well, I've got them labeled here, P0, 1, 4, and 3. So if I flip on P0, digital read of 0 is equal to 1, and digital read of 1 is equal to 1. When the thing is in the middle, it's mode 1. And then when it's flipped, 0 is 0 and 1 is 1, that would be flipped up. It'll equal 3, and then flipped down, it's equal to 0? And let's double check that. P0 and P1, octave select 1 and 2. Octave select 1, octave select, yeah, 1, 2, 1, 2, 1, 2, as 0 and 1. And the next ones are 3 and 4. And 3 and 4, when 4 is flipped, mode is 0, which is not the way octave switch works. Why? I guess these are calculation values, huh? So if, all right, this is getting weird. Oh yeah, mod. Where was that? Okay, hold on. Go back up here to mod. Where did that go? This is kind of like real annoying kind of coding here, but we are getting stuff done at least. Octave select is doing it in here right now. What we're doing is we're reading the switches so that we can report back on what the status of them is. So switch mode and switch octave. Oh yeah, this one should be a line. So we are bit writing the first 2 of these things, and then if SW1 is equal to, I don't like doing it this way, SW1 is equal to 3. I mean, I have to make a thing for each one. This is like a clunky way to do it. I mean, you could probably come up with like an equation that would make this. Why is that weirdly spaced? There's a space in there. I just do, well, it's 0, 1, 2. Oops. 0, 1, 2. 1, 2, 0. Actually, no, it's not 0, 1, 2, because it's actually the bits. You can only select one at a time. So it's either going to be 0, 1, 1, 1, or 1, 0. So 0, 1, 1, 1, and then 1, 0. So 0, 3, and 2. So in the event of a 3, octave switch is equal to 1. Now, what did I call that? What did I call that variable? Switch mode, switch octave. Mode octave. Strange, strange, strange. But I guess it's just like a switch state engine. That's not true. Switch state is a totally different thing. Switch octave on 0 is equal to, for some reason, this doesn't have to be like this. We could just punch it directly into the variable and then control it there. I'm just copying what this code does. So in the event of a 1, 1, it declares 1, but this is just an integer. So to be fair, I could probably just make swoctave into SW1, which I probably just should do. I'm just going to do that because it's so much easier than having a big if else. Just like that. And actually, I only need one variable because I'm that awesome. There. That's as easy as it can be. That is as easy as it can be. There we go. Easy peasy. So mode select is now going to be 0, 1, or 3. And just to remind myself, I'm going to go back here. There. Now I know. No, they don't have the same values as before, but when I put the rest of the code in, I'll be able to change what those values do. Because that's just all it's doing, is it's reading that mode variable and then doing one thing or the other. Octave, I think, might be being used in calculations, in which case I may need to change that around a little bit. So oct is in calcs. It equals, where did the window go that I was using? Okay, octave would be up 3, middle 1, down 0. Yeah, up is 3 in this case, 1, 3, 0. But we'll have to see how the rest of the code handles that, and I'll make a decision there as what I should be putting in. How would you do that, calculating-wise? 1 is 3, 3 is 1. I don't know, you could do an if statement somewhere in there to fix that, or you could punch in the proper value from now on. Our goal right now is just to test to see that my inputs are working. Let's get a button in here. So tools or edit. What are we doing? We want a library, and I want the examples, and I want to go to button 2. Button 2. I use button 2. I think it's probably pretty old at the, or sorry, bounce 2. I use bounce 2. It's probably pretty old at this point. There's probably a better bounce engine, but bah. Retrigger, duration, change, bounce multiple, bounce 2 buttons, and just bounce. Let's do change, and we'll see what kind of a read I can get on this. That's going to take a little bit to open up. So we'll include bounce2.h. Jeez. I am all thumbs today. Bounce2.h. Define button pin we already have. LED pin we already have. LED state is equal to low. I don't know if I like that, but I guess we could put that in if we really want to. So then at some point we need to initiate a bounce object. So bounce debouncer is equal to bounce. Bounce, bounce, bounce. Bounce debouncer, bounce, bounce, bounce. So where am I doing that? Settings, variable, pins, declares, I guess. Declares, boss. Well, we'll do a big hullabaloo for it. I can see that thing move. Hold on, let me make sure that I'm keeping up with the chat here. I am indeed. Let's see, this is our example. Bounce to bounce to bounce, and then in setup, we set up a debounce in milliseconds. So setup, set pins, make tables, set up PWM, start serial. Unbounce. And we've got the pin mode already established. And we don't have an LED state. But then in our loop, we update the debouncer. And then in my button handler, all the way down here, button handler. And I actually need to look at what is available to me on this. I mean, we could just take this code and we could just make it do exactly what. Well, we don't have an LED state variable. But I can just make that turn on and off the LED. We don't need to actually have that. Unless I do like a debouncer read state and get something out of that. Let's open up bounce 2 and see what we have available to us. Because I think I can make it shoot out a little serial thing that's a little bit more explainy of what's going on. That would be in app data. Actually, wait, I want this window. I don't want I need this window for my other nefarious work. My dirty deeds. I want to get this done. So let's get this code done. Let's go to app data. Go to local, Arduino 15. I really need to update all my Arduino stuff. Just throw it all out, start over again. Some of the deeds are done dirt cheap, yes, some of them. Others, you shouldn't be doing dirt cheap. What am I looking at? I'm looking for my libraries. Actually, I think my libraries are in my documents folder. Arduino libraries. Libraries. Bounce 2. Okay, here it is. Keywords. No, that's not it. No, that's not it. Docs. I don't need docs. Source, maybe? Yeah, bounce2.h should give it to us. Uncomment the following line for lockout debounce method. I don't need that. Class bounce. Attach interval update red. Returns the pin state high or low. Return high or low. Returns true if the pin signal transitions from high to low. That's fell. So red is high or low. Fell is high to low. Rose. Oh, that's if it goes up. Rising edge, falling edge. Duration. And those are protected states. So we don't get a ton of data. It does help us a little bit, though. Yeah, bounce 2 is incredibly functional. It really helps cinch up your code that interacts with things on the outside. I use it in just about everything that has a button. So which one do we want? I don't know. I wish I could get like fell and rose, like on a fell high low, you know, just gave me the, if it just gave me the immediate update of what was going on. Only call update once per loop. Return true if the pin state changed. I could return that if the pin state's changed. We'll just do red. So in order to do that, what we need to do is we need to do where is it? Debouncer.red is equal to, so serial print debouncer.red. And then we'll do in serial prints, serial print wall, no end line, button, and then serial print line debouncer red. And that should give us a high or low. It'll be a 1 or a 0 probably. I don't really know what it'll display, but I really don't know what it'll display, but at least it'll give us something. I think that's all we need. I think that's all of our stuff. All of our stuff's coming in. Oh, if yeah, button handler stuff happens here. Mode stuff here. And then test LED, we're gonna do respond to button. So we'll just put in this code, which means we need another variable. This thing, the RP2040 handles so much code. I like, this is like nothing for it. It's just the complexity always bothers me. I like to keep my code simple. I guess I could always do like a mode if the variable's even or something, but let's do, I'll do an int, whatever. Hey, Pyro. LED state. Actually, bool. Bool. Not capital, not insert. Keep hitting insert on this tiny bool. There we go. Bool LED state. Hello, Pyro, and all the other refugees from every streamer on the planet playing Dragon's Dogma. 2. Some got early copies. Some are going to be playing at 8 p.m., which is 4 hours from now, which is a batshit crazy time to release your game. But I guess that's just, they're doing a global release, so they have it all at the same time, all around the globe. And I guess LA is the one that gets 5 p.m. We're going along just fine. I've been avoiding polynomials. We did a bodge job in order to get the thing just running. And then Ben Gizmo had a suggestion for changing some values that cleaned up our wave a little bit. But down there you can see I did a little bodge job in order to get that chip running. And right now it has been just outputting a fixed sine wave on the scope, which you can see right there. But when we zoom in, things get a little rough. I don't know if there's a way, like with further filtration, to clean that up. But I think it should sound just fine. It's a nice clean bod, as clean as I can make it. Polynomials. You shut. Yes, I need to look at these things, and I need to figure out what polynomials I can pull out of this thing so that I can have it more algorithmically, get to use that word, put together the wavetable when it calculates everything, because that would be much better and cleaner to read. So I've been kind of splitting them up. You can see down here, I've kind of split them up into common stuff. And I think this is this. I'll have to look at it again. But I just need to figure out how to put, like, what is the penultimate equation? And then I need to have things default to a non-value that won't influence the output. And then I need to have the sections in here that come in. And then I can make it sort of a much easier to interpret kind of thing, because the variance in between them is just individual values of pieces of the polynomials. But that's all like algebra stuff. I wish I could find the derivation of this, where they came up with these different sort of, what are they, just modes of whatever. Modulation, there we go. Modulation is the word I was looking for. But right now we're just going to set up to check to see that our all our stuff happens properly. We get all of our stuff going on. If debouncer fell, LED state is not LED state. So we just do that. So it starts at 0, and then we just have it do its thing. Oh yeah, I was saying last night, Flatulent, I put on a random episode of Trailer Park Boys, and it happened to be the "That's a nice fucking kitty right there" episode. Let's see, debouncer.fell. We can get rid of all this stuff. I don't need to have this stuff in there. We just need to get our variables right. So instead of LED pin, it's actually octa select button, blah 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 blah. Panel LED. Panel LED. It's 1L because I strive to confuse myself with the names of my variables. Yeah, I need the thing that Gonad Stream does is when you put it in the AuCAD, it goes, "That's a nice fucking kitty right there." I do need more zany stuff. That would be a lot of fun to figure out. But then I'm gonna have to use his setup, like Loran board or whatever the hell that is. I don't know. I don't know if I want that. I don't know if anybody wants that. It sounds awful. Let's see. The variable that we just made is called LED state. Oh, it's the same exact variable. Good. Okay, so that all now should work, and we should get a serial print that's a nice long line that just goes line by line by line and tells us what's going on. These are important programs to have when you're doing stuff like this, because you take all the complexity away and you make sure that your hardware works. Loran board is dead. Leoran board is dead. Use Sammy. Oh, okay, so that's why you talk about Sammy so much. Sammy, you're breaking the car. You are breaking the car. Pay attention, Sammy. Turn right into hard left. Sammy. Please, Sammy. Okay, so let's apply this. So I got to plug it into USB. Theoretically, nothing should blow up. There's a little bit of isolation between the things, and we'd be pumping 5 volts onto the wrong side of a 3-volt regulator. Our 3-volt regulator, I think it'll all work out. This thing should be designed to be plugged in while it's powered. Well, nothing blew up, and my USB probably still works, and we're still making a waveform on the oscope. So, and if we use the Arduino with, oh my god, look at all the configuration. If we use it with the COM port, it doesn't need to be, you don't need to hold down a button and plug it in. Like, there's all kinds of ways to program this, and I guess if you're doing like Python, MicroPython, you can throw a file in a folder, which is interesting because the first instinct for people just starting out with microcontrollers is, well, there's code on it already. Can I get the code off and look at it? And it's like, no, the compiler turns it into hex, and the hex is completely batshit insane. Nobody knows exactly how it works. If you want to do that, you can get software reverse engineering tools that will help you go through and reconstitute all of the loops and stuff, but you're still not going to get the full picture. I have a buddy who makes 6 figures doing stuff like that. But anyway, so you can't really get the code off until MicroPython came along, and we got an era of code where you just put the file into the thing and it functions. It's nice to have that. What happened here? Something happened. Mod wavetable times mod F, mod was not declared. Wait, are we sure about that? Because I fixed that one already. I turned it into a 1 int mod 1. So let's upload our code, I guess. Oh, mod F. Oh, no, never mind. There we go. Dun dun dun. Bounce2.h. No such file or directory. What are you smoking? We looked at it. We found it. It was right there. Examples. Where's bounce2? Let's open up a bounce2 example and see what's going on. It's not in the RP2040 things, so it's not. So how do I get to there from the RP2040? Do I need to do... They have different root directories. So in libraries, I've got all this stuff. Oh, yeah, you're probably right. Case sensitivity. Weird that they would have it capitalized. You're probably right. Let's check. Did I not hit the button? Oh, there it goes. I'm confident. Damn it! Button pin! Bitrate, switch 1, digital read, octa-select. Value, bit, value. What's going on here? SW1 was not declared in the scope. Oh, I left an SW1 in. I left a thing in. Let's get it out. Nope. Ah, there it is. And then the other one was button pin. I think that's all the way up top. Yeah, button pin. Debouncer attach button pin input pull up. And then in my, I guess I don't need to declare that as input pull up in my setup. And it's BTN. Go. Try again. Got multiple errors at once. We're firing on all cylinders. All of our synapses are sparkling off. Our brain is starting to get a little bit melty from all the activity. It appears as though we've gotten away with murder. Yes. Damn it! Oh wait, no, that's good. That's good. Even though they're in orange. And we wrote our code. Let's take... Okay, so the controlling the amount of zeros on it does have a bit of an influence. So this is our mad serial print. I know that there are tools that can let you like clear these things out. I don't know how comprehensively Arduino has those, like mode and stuff like that. Like, okay, so mode says it's 3. Flip the switch, mode 1, all the way down. 3 in the middle, 2 is up. Sweet. Octave, down, middle, up. Look at that, beautiful. Let's change this one here. That's the frequency pot going from 0 to 1017. And then we've got octave pot 1017 to 0. Sweet. We could always mess with those sensitivities, but let's take those both down to 0. Captain Planet would be proud. And then the button, if I push the button, does the LED come on? No. Okay, we'll have to work on that one. We'll take a look at our button code in a minute. Now, for the CV ins, right now we have 500. So the question is, if I take a voltage into there, and I can't show everything at once, can I? So we got the scope here where we can actually monitor on channel. I can turn that into channel 2. I'll have to plug this mess in. Blesses this mess. That's kind of difficult. I need like little attachy BNCs, like little short run BNCs that I can plug these in with, because these T adapters aren't the most elegant thing in the world. Okay, well there's that mess. And then I take this pin and I attach my power supply and I go to volts, which is +6 all the way over here. As you can see, like way over there. There we go, that gets more of the desk. And then I plug this thing in to one of the CVs. Right now it's at 0 volts. So CV in, this should be CV in number 1. And I'm gonna take it to 5 volts. So 5 volts on that, and it looks like CVN2 is that one. CVN2 is actually the one that's down below. Now what was that? What did Hagiwo mean for that to be? What did Hagiwo mean by this? Is he stupid? Let's see. Hagiwo, V per octave, and then mod CV. So we'll rename it to V per octave and mod CV, because that'll give us a better impression of which one's which, because mod CV goes up there, V octave, and then mod's on the right. So currently in 2 is V per octave. I'll call it that down here in our prints. Voct CV, and then what was it again? Mod CV, yeah. And then let's just double check. Yeah, mod and then Voct. Okay, cool. Save that. So that should be pretty clear. Printfs would probably be better. They take a little bit more time, but you can also make them a certain amount of space, and then your serial print won't grow and shrink as you go through those. They feel more like plumbing parts when you get a load of them joined together. They really do. You feel like you're putting together some kind of infernal bong made out of old plumbing parts that you found in the basement. Not something that I have direct experience with. but it really does feel like you're getting like brass lamp parts and you're putting them together in a weird way. So CV2 in 2 is equal to 2. So that is, let's go up to our in 2, which is the volt per octave. So V per octave, octave volt in, low equals high, low equals 5 volt, high equals 0 or negative 5 volt, and actually 0, 1024, make it 5-ish. 5-ish. 0 to 1024, and so for the CV we should be seeing the same thing. I'm going to take the cable, I'm going to unplug it, and we'll go to mod input. That's a strong 1 at 4.996 volts. Mod in. Where'd that go? What are we highlighting? There you go, mod in. Find it again. I should just find replace all of them, but I don't trust find replace. Not after the accident. That's it. Okay. There should be only a couple places that you call up pins, and so you call up pins at the very beginning of the program, you call them up when you declare them, and then you call them up when you load them into a variable. That's it. 3 places. That's how we code like professionals. Although, you know, sometimes you read them a couple different times, but that would be sort of a weird corner case, because in terms of the way that a device like this functions, you want it at one point in time to say, this is the status of all of my inputs, and then like a couple milliseconds later, this is the status of all my inputs again. So, okay, so the LED is not turning on. So what's happening there? What did we do? Let's see if we can get our LED to actually do something, or if it's orifice, or if it's something that I'm doing. Pin mode, panel LED output, which means it can be a 1 or a 0 with a digital write. We have our bounce object, bounce2 is declared. We declare bounce debouncer is equal to bounce. So whenever we say bounce dot, but it's capital B. Oh, okay, so that must be it. Capital B on the bouncer. So, oh, but it's a debouncer. Oh, debouncer is the object. Okay, I don't know how this stuff works. Chad told me how this stuff works one time, and it leaked out of my freaking ear like a minute later, and I wish it didn't, because declarations are really, really powerful in programming. You can have like a structure that you declare and stuff like that, like, and then you can call upon things inside of that structure, and it's like super cool, and you feel like you're hacking the planet. But yeah, it's just these things confuse me. So debouncer is what we call it, debouncer dot something, and then that's one of the structures that are inside of it. There's only a couple. There's high, low, falling edge, rising edge kind of stuff. Print line debouncer dot read, and then in our serial output, button is 0. That's not working. So it's either not reading the proper thing, it's reading a bad pin, or the debouncer doesn't work like this. Cool. Bool bouncer is equal to debouncer dot read, and then print line is bouncer. I don't know if I spelled that correctly. I'm going to use the magic of copy and paste. probably should separate out the functionality of the LED and the button. They shouldn't, one shouldn't control the other in this program, because this program is all about vetting out our hardware. And if we put two variables on one thing, then who knows what's broken? It could be the button, it could be the LED. Dang it. Error opening serial port. Oh yeah, I gotta close serial to upload the code. Bop. Bop. It's funny, some of the microcontroller packages don't do that. I think the Teensy doesn't do that. You can leave those windows up because it's using a different thing to flash it, so it doesn't really need full control of the COM port. I think it has to get into the COM port and reset the device, and then it leads the way. Okay, so still no word from the button. Why would that be? I'm gonna hold the button down for a little bit here. All right, so here's what I'll do. At the end of my setup, loop, setup, let's do WAV, read analogs. Where's setup? Setup is way up here. That's our loop, our main loop. This we don't need. So we have our debouncer update, and then for some reason we set an oscillator frequency there. That's used in calculations later on. But debounce interval 25 milliseconds, BTN. So digital write panel LED high. We'll just see if the LED turns on. So that'll vet out whether or not the LED is done properly. We're not seeing it in the serial print, so I suspect it's fine, but I'll just do that so that we know that we've gotten through setup properly. We know we're getting through setup properly, so that LED by all means should light up, but if I put it in backwards or something like that, there it is. Okay, so the LED pin is fine. This is something about the button. And let me see if we can see anything happening with the button. Nothing. Yeah, nothing at all. Okay. So how is the button being handled? Let's double check some stuff. We go from the button down here. Could it be shorted to ground? Well, then it would say button is state as 1, wouldn't it? It's possible I put the button in. Well, no, but these are a little bit slightly different distance on the rise and the run of those pins. It wouldn't fit in if it's turned 90 degrees. So that's the logic of these buttons, is that you can't really, you can certainly put them in wrong, but you shouldn't be able to easily. So this comes out and around, and it goes to P6. P6 is pin 1. Pin 1 is an input pull-up. If I use the multimeter on this, I could probably very easily figure this out. Let's check. I gotta close some windows here. Check our program. Octave select 2. Oh no. D4 as in P6. So I need the page that has the Seed Studio pins. That would be this one. And the button that we are plugged into is the upper left, P26. No, that's not right. Oh no, we're looking at the opposite side of the board, but the RP2040 goes in that way. It's not flipped. Huh? Wait a minute. I've confused myself. I've hurt myself in my confusion. Yeah, it is pin 1, P26. That's an analog input. That shouldn't be. Oh no, never mind. Sorry, P26 is different. We're P6. We're pin 5. 1, 2, 3, 4, 5. P6, D4, P6, D4, BTN. Let's see, pin mode. This one has it button and then input pull-up declared here. And then I commented out the one that was in the, wait a minute. Oh, yeah. I commented out this one. Button input pull-up. Debouncer's attached to debouncer. Debouncer updates every loop. I don't see why this wouldn't be working. And then we're putting the if debouncer.fel LED state does not equal LED state, and then digital write the LED state. So I should be flipping this off. LED state is a variable from all the way up here. LED state, Boolean LED state is equal to 0. LED state is equal to 0, even though we set this one to 1. That should override it if it's running. Wait a minute, if it's running. Test LED. Test LED, damn it. Why wouldn't test LED be handling? Because the pots are updating constantly, so the test prints and stuff are happening over and over again. So test LED runs, and what does test LED do? So read the analogs, handle the switch. We have a button handler that we're not doing anything with. Test LED. If debouncer.fel, LED state does not equal LED state. Digital write panel LED with that variable LED state. This is as simple as it gets, and I don't understand why it wouldn't work. Debouncer.fel is running right there, and that should be totally, that's exactly out of the example. And yet, for some reason, it's just not doing anything. It's exactly out of the example. I mean, debouncer.update handles up at the top of loop. I don't think anything else would unseat its value. LED pin, LED pin. Wait, did I declare the button pin as the... Oh, that might be it. I might have declared the wrong stuff. Hold on. So we want BTN. No, we did. Button is input pull-up. The bouncer attach. Bouncer update, bouncer LED, blah, 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 blah. Do WAV, read anal, switch handler, button handler, test LED, debouncer.fel, LED state does not equal LED state, digital write, panel LED to the LED state. There is no reason why that should not be working, unless my switch is in the wrong way. Maybe the switch is in the wrong way. Hold on, let's take a look at the hardware now. The code is as dead simple as it gets, so let's get that scope off of there. No volts DC. Hold on a sec. I think my switch might be in wrong. In which case my part is wrong. That can't be. Yep, that be. That indeed be. I think the switch needs to be twisted, which I think is a part issue. So this is why we test. Welcome to the finding out portion of the stream. This is why we test these things. So if I go to this switch lead right here, where is that? Oh, hold on a minute. We're still in the finding out phase. Hold on. So like this switch lead, versus ground. Gotta find a reliable ground here. There, so yeah, that switch leaves at 3 volts. So if you switch it, it goes down to 0. But if we look at the button over here, it's at 0 volts. What about this one? Also 0 volts. That one is supposed to be at 0 volts, and so is that one. So I need to cut off that switch. Well, we need to characterize the switch. No, it's already been declared as input pull-up. Let's take a look at the switch here real quick. Which switches did I use? Which ones did I use? I have a whole kit of them. Here they are. Well, these aren't the exact ones, but they're close. They're done the same way. These tactile push-button switches. If you need a button on something, these things are a great go-to for putting on a button. I thought the SparkFun part, or whatever part I used, would be pretty accurate for it. But turns out, maybe it's got it flipped. Flip you over to ohms. You're not remote piloting me. I'm a being of free will. All right, so let's see. So on one side, from thing to thing like this, and then I push the button and they connect. That's not the way that this part was laid out. So this thing is wrong. Oh boy, here's another issue. And we can get this one to work. I'm just going to have to do a little bit of work with the actual traces. It turns out this thing thinks that these two are the same, but they're not. Those are the switched elements. It goes across like that. So I need to go into this part and edit it and fix this mistake before it hits me again. This is one of those things where, like, you don't find out about it until you actually print the PCB. And the way that I can get around it, I guess what I can do is isolate. I have to isolate the diagonals. So I need to take that lower pin and the upper ground pin, and I have to isolate them out, scraping them with a knife from the back side of the board. And actually, before I edit this part, let's just confirm that that's what's going on. So I'll turn off the Agilent power supply so nothing's going to my board. And then I'm going to take the knife. Oh yeah, let's unplug our Pi as well. And then I'll take the bottom side of this board and I will scrape it. Scrapey, scrapey, scrapey. Let's see if we can actually get this on the vise so that we can see what we're doing. With all the stuff plugged in, it doesn't sit flat. All right. Yeah, let me unplug all the stuff, I guess. Both buttons are done the same way too, so that's a little surprise. So that's over here, and we basically just free up the diagonals. I'll use the knife again. I mean, the scraper tool that I have is pretty cool, but it's apparently not that useful. I mean, it would be useful for this, because I could just put a huge trough in between these two. But what I'll do is just grab that one there and peel this up in between. Make a nice big opening. Whittling away circuits here. I am never getting this color of what do you call it? Solder mask again. It's hatefully bad to work with on a prototype. Like, it's fun to get all varied colors and circuit boards and stuff, because there is a lot of really cool art out there, but it is just obnoxious to work with in this capacity when you gotta get in here with the nitty-gritty and scrape away stuff and claw your way to an actual working circuit. This one's going to be a little bit harder, especially considering that I can't see what I'm doing. I have 4 prongs to delete. So we can just pry up the copper. Give me that copper. Maybe not. I have to scrape them. If I could scrape the solder mask off, then I could at least see them. And then isolate them out. Scrapey, scrapey. Just remove everything from this whole area. This is like these two connect. And these two connect. But these two connect. These two connect? Wait a minute. Hold on a second. This is the one that's at 3 volts. This is the one that's at ground. This is the one that's at ground. This is the one that's at free. I need to do a little bit more testing here. Ohms. Let's see. Where'd the switch go that I had isolated? I need to not confuse myself right now. So if I go from this one up here, I think it's top and bottom are connected. Top to top, that's ohms. Top to bottom corner, that's infinite. Okay, yeah, so it is corner. It's actually this one and this one are connected, and this one and this one are connected. And I can fix that in the part just by reordering how stuff is put together in the parts diagram. Right now, I need to isolate this one out, or it's going to be infinitely grounded. And I didn't have, well, yes, I did have to isolate that one. So it wasn't infinitely at 3 volts, or at whatever the pin voltage was. Motion detected at the front door. I don't know what's going on out there. Gotta cook fajitas in a little bit. All right, that one seems isolated. As best I can guess, because I can't see what I'm doing. Make sure we're isolated down here. Let me just do like a scrape around. Do the whole perimeter. Not the most elegant edit that I've ever done. Let's see, there's probably still continuity. Let's just check. You and any of you. Damn it. Still continuity. I gotta scrape it a little bit more. I just wish I could see where the damn traces are. It's like further in than where I'm scraping. And although this is totally ruinous to the board, it's fine for prototyping. You shut your stupid popular mouth, Mr. I have 200 people watching me smoke. As is typical with this kind of stuff, anything you don't check is in a quantum state of broken. So the mistakes are all there. If you don't check anything, they'll default to broken. And so what we've done is we've made a little program that has output all of our serial prints for all the stuff that's going on this board. So using the RP2040 and the batshit insane Japanese coded pinouts, I took my leave to create a program that does like the basics of serial printouts. And now we can see what the state, oh, it's not plugged in right now. I'll plug it in a second. We can see the states of all the inputs. And so in doing so, we discovered that the button's not doing anything. And as it goes, the device that I put in as the button was not properly pinned So you can see here that I've got the right side and the left side. It's actually the top and the bottom that are the ones that are the same. Yeah. Yeah, it's, oh, you know what? You bring up a good point. You didn't even realize that you did. Damn it. Okay, so that makes it a lot more work to isolate. I'm going to clip the lead. I'm just going to clip the lead. That's the best way to do it at this point, because we've got a top and a bottom layer that are both connecting that thing. So if I just clip the lead, then we can isolate that one out. The other one is okay to be connected to ground, and it was only connected on the bottom side. So my little trace edit there is perfectly fine. But it's the top and the bottom both. You said like top or bottom or whatever the hell you perverted thing you were talking about, and that made me think about the top layer. So yeah, this thing is connected on the other side of the board. So we've got to, oh, that's super easy to get my clippers into there. It's not. It's really not. So which lead was it? It was the inside top. It's that one right there. And I've got to somehow rid this entire switch of it. So you guys are ready to capture the arterial spray, right? Of me slipping and putting a knife like 2 inches into my arm. There we go. That should isolate it pretty good. Just make sure the lead is bent out a little bit. And now we can, well, I guess I can't. I can test this pin over here and make sure that it's not on ground. Put this down before somebody gets hurt. It's a scalpel blade. It yearns for flesh. Please feed me. No, scalpel blade, I can't. Oops, you guys can't see. 2M. And when I push the button, I need 4 hands. 2M, when I push the button, goes down to 0.6. Okay, now the button is functioning the way it should. Like I said, you got to claw your way to having a fully 100% functional circuit board when you do stuff like this. We had 3 errors actually. One error was that the power plug was upside down. That was something that I just simply didn't check. I was too arrogant to check for something like that. So luckily, this thing is a square, so we just flipped it over. But I corrected that in the main document. Next, we had a plus and minus from an op amp flipped. Again, because I'm completely arrogant and I thought that they were all in the same orientation. No, one of them was flipped. Then we discovered, what was the one after that? I think it's just this one. Then we discovered that the switch is wired wrong. These tactile switches have a pretty universal system where you've got kind of a wide stance here. It's kind of a rectangle, and the top, if you think of it like you put the short pins on the right and left, the top pins are connected and the bottom pins are connected. Some switches are different than that too. Never had a PCB work first run. I have been blessed to have that happen to me very occasionally. I forget which one it was, but one of the doodad things that I put together actually did work the first time. Yeah, adding 2 extra hands. I'll do a Doc Ock. But yeah, this one is fraught with various random little issues, and you know, it's gonna happen, especially when you're streaming and you're burnt out as hell and you have executive complete dysfunction going on. So let's plug this thing back in. We'll observe our ooh and ah waves going on, and then we can also see the wonderful button work do its work. See what happens when you don't remote pilot your streamer? You know, you don't try to remote pilot them so we can actually work, and then you get stuff done. It's kind of cool. All right, let's plug this thing into power. So I'll need to do the edit on that part, and then things will go pretty smoothly for the rest. Power's on. We are drawing. Oh, that's over. Wow, 0.043. 12 volts is 0.33, but why is 5 volts drawing so much? It's just going into an op amp circuit. Is anybody getting warm? Power supply is getting... What's going on down there? Why is that getting hot? Are we... maybe I'm putting the wrong thing into the wrong thing. Yeah, I was putting the wrong thing into the wrong thing. There, 0.28. Ah, luckily it didn't damage anything. It looks like we've still got signal. Look at that awesome feature, the scope. The scope rules. It rules. It's so awesome. Let me open up the serial monitor. Yeah, I got a new Rigol for my 60th birthday. I hit a nice round open number, the big 70. So for my 70th birthday, comms not available. Wait a second, what's going on here? Oh, I didn't plug in USB at the top of this thing. Yeah, for my 70th birthday, I bought a new scope. This one has a signal analyzer on it. Get a whole analyzer on this thing, and it's got the Ethernet connectivity. It's also USB-C. So Amazon, instead of sending me a dog toy, sent me a $75 USB-C power supply that I'm now using with my scope. The scope gets first dibs on any power supply in the lab because it needs clean power. We put a non-reflective thing on it, and it's also touchscreen, which is pretty cool. But the cool part is when you plug it into Ethernet, it will open up the scope interface on an intranet site. So it's not outward facing, but you can go in and you can actually click on the screen. But I'm putting it up in OBS, which is kind of amazing. You guys get a real-time view of what's going on in the scope, which is pretty awesome. Especially for reverse engineering, when I'm looking for like a spurious signal that flies by in like a millisecond, I can do that. Putting electrolytic caps backwards can be fun. Yeah, there's a nice audio-visual reminder of your failures. Managed to add a smoothing cap in series with the power instead of parallel in one of my PCBs. That's a weird one. I've had ones during like the PCB 1, 2, 3 era where I've had a trace going horizontally across the entire design because I thought I was putting it on the lower layer instead of the upper one. Button. Yeah! Yeah! Look at that LED go. Look at him. Button. Button, button, button. Yeah, look at that. Beautiful. Yeah, that's what I did with the old Rigol. With the old Rigol, I would put the scope down in front. This thing is also thinner. Look at that. Beautiful. But yeah, the scope is thinner. It's just so much better. Hold on, let's look at the serial outputs real quick. I just want to revel in them. Oh, USB. Keep getting distracted, guys. Where's my USB? There it is. Yeah, but I mean, for your style, whoa, it's probably better to just put the scope out in front. But when we're doing like hardcore stuff and really getting into numbers, it's nice to be able to train the scope on something else and people can see where I'm poking. The LED of success burns bright, my friends. Cool. So with that, and with this serial thing open, let me add I'll add a scene, hold on. Window capture. And it's gonna be, serial. Oh, it guessed correctly, huh? That's not very visible, is it? We'll make it big, and then I'll put it, like, down. Where is that? It's above everything. Oh, God. Nope, that's the wrong one. Nope, that's the wrong one. I need to bring this sort of over here, and then I need to... Where is that? I need to do... Well, those aren't going to show up unless this thing is way below. Put it all the way down here. Let's put it below the scope. There we go. And turn it on and off. And then, why are my audio things... Okay, hold on. And then... What is that? Why is that coming up? That shouldn't be coming up. What is this one? No. I don't know where these files are. Let's turn it off. Okay. All right, let's get serial back in here. And I'll make this, let's do that. Let's cut it from above. Okay, so knobs. Octave pot. All the way up. All the way down. These are in weird order. All the way up, all the way down. Frequency pot. I actually think these are flipped. Is it supposed to? It's supposed to. Wait a minute. How does Hagiwo have it? Probably has frequency on the top, doesn't he? Hagiwo, what did you do? Let's take a look. You frequency and then mod is below it. So I've got them flipped. Well, hey, guess what? Hagiwo, purveyor of code that puts numbers directly into the code. If you do something like that on the program that I've structured, the fix is so much easier because all we need to do is go up to the top, and then I can take my two pots and I can just flip them. Bam. Okay, I messed it up a little bit. Save. We'll upload this. I splurged. I got the super amazing scope because we'll use it eventually. Some of the features in the scope are truly frightening. Not to mention just the weird internet stuff that it does. I can do like split screens. I can do all kinds of logic analysis. It'll be kind of amazing. Error operating COM4. Oh, yes, we gotta close the window. I do know of Handtech. I don't know if I've used their scopes before. Tea, Earl Grey, hot. It'd be nice if we could make tea. I could really use some caffeine right now. Then again, I'll be up like until 3 a.m. if I have any. All right, so that's up there. Open this back up, and then we can look at this view. Oh, and it remembered the window. That's nice. So yeah, octave switch. Actually, let's check to see. Hold on, wait, which one's which? Which control is which? I'm just gonna get these, finalize these. They're not really fold FM AM and then octave. So fold FM AM on top and then octave on the bottom. So if I switch this one, octave switch 3, that's mod and octave. So I need to flip mod and octave around. I need to change these P0 and 1. And again, because we've structured the program the way that makes sense, it's all right here. So P0 becomes P4. P1. Oops. No. Wait, redo. Wait, Kyle. Redo. How do I go forward? There we go. And then P3 becomes P1, which is that one, I think. I screwed this up. Hold on. Wait a sec. Let's go all the way back. P0, because they're in a weird order. They're in a weird order. P0, P1, P4, P3. I'm confusing myself. So P0 becomes P4. P0 becomes P4. P4 becomes P0. And then D7 go into here. And this one go into here. Okay, that should fix it. I can fix her. Close this, upload this, and then we'll check it over. You can control it via SCPI over USB. Yeah, the 1054 that I had would do 1 update per second. It is amazingly slow. We did all the tests. People have come in and been like, the 1054, you can hook that up to Ethernet and stuff. You can hook that, yeah, you could do this, you could do that. And I'm like, I've installed all the tools and I've tried them all because it's having that scope up on the screen has been a wish list thing for me for all the centuries that I've been streaming, and I've never gotten to have it until now. But the old scope was extremely slow. It was incredibly slow. All right, so this one is fold FM AM. So you see the mode switch, fold FM AM. And that's just the modulation, I guess. Probably should be called mod, not mode. This one is the octave switch, so octave 1, octave 3, octave 2. Those obviously, the 3 and the 2 are supposed to be, or no, 1 and 3 are supposed to be reversed. This should be 1 octave, 0 octave, and whatever anyway. It's 0, 1, and 2 is the function of that switch, but we're taking just the direct bytes and interpreting them. Then we have the mode switch. There's the button going from 1 to 0 and changing the state of the LED, so we know the LED works. We've got a sine wave coming out, so we know that the output works. Potentiometers. This would be the... I gotta look at the picture again. This is the mode or mod pot. That's wrong. Well, this one is the frequency. So octave pot, I guess, is mod. I should probably call that mod pot. We go from 0 to 1024, or in this case, 1018, which we could scale if we really wanted to. 0 to 1018 is pretty good, though. You're only missing a couple values in there. And this is 0 to 1017. I need to order more of these so we can do the, what do you call it? The chord VCO. So, all right, so plugged into the power supply is 5 volts on the left here. 3, 2, 1, 0. You can see volt per octave control voltage. Now, if I take the leads all the way back here and I flip them, now we have -1 volt going in there, and volt per octave CV is at 600. And we do 1, 2, 3, 4. 4.997 volts equals 1010. Pretty good. 3, 2, 1, 0. And that is the volt per octave CV, the one on the left there. This one is the mod CV. So I come over here and I go to mod. Our mod CV is now at 607, which is a ground state pretty much. It's at 1 volt, so, and then we take it up to 2, 3, 4, what is this power supply doing? 4.99, and we're at 1013. Take it down to 0, flip the leads. We're doing it! Our circuits work! All the values that we put in these circuits are working. 3, 4, positive 5 volts. Positive 5 volts, and our number is 0, and if I go up to 6, which actually we're at right now, it's at 0, and if I go to 5, it's still at 1. So what's happening is it's maxing out, and it's not harming our circuit. All of our hardware works, and it is now vetted out, and we found 3 mistakes. I told you guys we'd find more mistakes. Beep, 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 beep. Look at the numbers going by. Hey, cool. All right, so this is progress. I need to go look at polynomials. I need to do coding tonight, I guess. Either that or we're going to do it tomorrow. We're going to sit here and scratch our heads and our balls trying to figure out what this giant polynomial is even doing. It's like they modulate something. If you want to look here, if you want to see what this thing is actually outputting, all we need to do is drop in on the right part of the circuit. Which one is it? Hold on, I gotta look at which one it is on my designed. Scratch your head and pat your balls at the same time. I don't know about that, Dins. That seems pretty complicated. I think it's this one. So this one right here. Oh, is my channel 1 not active? Now it is. And we should take it down to 3 volts. There we go, 3 volts, peak to peak there. And we're gonna look for whichever pin is the output, the audio output. I guess I could just look in the code. Let me open up my code. It's always hard to find. Which one are you? There you are. Audio out D8 or P2. Which one is that? D8, P2. Oh, I think it's over here. Might be this one. Damn it. Yeah, so this is what it's turning in to actual audio. And the filter is what makes it into a wave. It's that Schottky key filter or whatever. Not Schottky. Salin key low pass filtering is what enables this mad looking PWM to turn into a beautiful butterfly. It's very strange. But I guess it's the key to all this. It's a funnier character than we ever had, and we'll have to make him work. That was a Jar Jar Binks joke. I have no idea, but somehow all those polynomials go through and actually make this thing function properly, which is pretty cool. So the next thing to do is to make it respond to frequencies, and in order to do that, we will come back here tomorrow and we'll work on that. Whew, that was a good conclusion. That was a nice place to be at. I can't believe that I got the button, the switch wrong. I mean, if we do take another, yeah, we'll take another 5 minutes and I'll correct my button transgressions. So I want to view the bottom layer of the board, and I'm going to have to do a bunch of edits on the other board as well. So preset bottom, and then we are looking at the bottom from the bottom. I don't think I have a ping. So I want to edit this part. I guess we got to go and look at it on the schematic. That would be the best way to get into it. And so this button is wired incorrectly. Properties, or no, cancel. Open component. So I have 4 pins. Oh, this is a wonderfully useful view. There we go. So it's actually, oh, and look at the symbol. The symbol has the switch like that, which is not correct. Let's double check. Twitch is in Comic Sans. What plugin do you have? What would we be? Probably Silkscreen Top. Oh, they don't have it on this symbol. Where's that? Is it like, it's not in values. Huh. There's like a little symbol on this thing, and it's not, that's not correct. It should be over here. I guess it's in a weird spot. Okay, so either way, what that means is that I need to change these, and if you go to edit this 1, 3, 2, and 4, it's 1, 2, 3, and 4. So disconnect the whole thing, and G1, 1, and then we append 2, and then we connect this one and append this one. And save. We save the crap out of this. User saved. FFC, but I default it's set to console. Maybe it just got confused. The image on the switch is correct. No, it's not. No, it's not. 1 and 2 are connected. 3 months after I bought my first 3D printer, I went to buy a new one. Is this normal? Yes. It is. Actually, that's abnormal because the default state of the majority of 3D printers out there, if you do the calculation, you'll get the default state, and a working printer is an outlier. So the oh yeah, you're right. Yeah, you are right. You are right. You're correct. It is between the top and the bottom. The connections are the two. Yeah. This is why I always get it wrong. But the normal state of a printer at t is equal to 0 is broken. Right? So they're always broken. All of them are broken. Those of us with a working printer, we're rare. We're a rare breed in the grand scheme of things. Most of the time, it's broken or broken and disassembled. Those are the default state of all printers. So if you look at, well, how are 3D printers doing? They're all broken. That's a safe assumption. Having an actual working printer is a rare thing. So no, you're a freak. You're an absolute freak. You're an irredeemable freak for having a working printer. We need to upload this to library.io. Why is beyond my comprehension. I just do the things. And if I'd gotten that right at first, I would have saved myself all of this trouble. Madamuse says, my makerspace has 4 printers, so we always have at least one that works. I want to get a resin printer so I can do tiny little RC car bodies, but at the same time, I don't want to have to deal with a resin printer. They're a lot to deal with. I would like to make a DIY CNC. We have all the parts. I have all the parts to make a DIY CNC, like a little thing that I can do to cut out carbon fiber. MakerBot Cupcake. Huh. I wonder, my local micro center, I've never not lived near a micro center. And I have a feeling they might have something like that. I don't know about the bamboo cupcake, but I know the Eggbot, they definitely have. You know, you sitting on a dusty retail shelf. All right, so my view is totally stupid here. Display layers, let's just do default preset bottom. Look at my bottom. Preset top. There we go. That undoes all the stuff. Preset bottom. We need to update the schematic, otherwise the CAD software does not know that anything has changed. So we go with the schematic, and it's going to be like, hey, stuff is updated. Maybe not. You need to update the parts with the... It might stand to reason that I just need to go through and redo. Hold on, let's check. Library. Update design from all libraries used in design. The library update has modified the board. Perfect. They have an Eggbot? I'm not sure. I'm not sure if they have an Eggbot. I do not know. Oh, well, that's a little clunky. But what I'm saying is, like, one might end up on a dusty retail shelf somewhere. You know, you might luck out. Micro Center has all that kind of crap. They love it. They love it. And we love them. Dear God, what have I done? Control Z that as hard as I can. I guess we'll leave that via there. Put down a trace, and this one is not a power trace, so it's probably 0.3. 0.3, yep. And so I'm going to put down a curved trace, because we use curved traces. 0.3 millimeter. I've tried to get all of my stuff to go over to millimeter. It's there's been a bit of a learning curve, but millimeter's nice. It's a nice unit. Okay, that is fixed. The other one is not. The Cord VCO is not. Really, MakerBot the company? Are they like imploding? This is a little clunky here, isn't it? Oh well, you know, I probably should turn it around, and that would be a lot better. But we'll just leave that the way it is. Yeah. What did the Cupcake bot do? Was it just like a thing that spins a cupcake and moves the motor back and forth, and it like poops frosting all over everything? Okay, so like if I had ordered these with the first correction, I would have been completely SOL in terms of like, that would have been horrible because I would have had all these other errors on the board. It's just the very reason why we check literally every single atom of the board when we order them. If you want to get an order in and you want it to be done correctly the very first time you order a board, you need to go over this with a fine-tooth comb, put it in the back of a closet for a month, and then come back to it when you're fresh and check everything over again, because just stupid little mistakes will happen on these things. You know, we have plenty of experience with them. You guys got to see several get uncovered during this stream. So now that we've got our shit together, we can actually, I can order boards in the future, but for right now, I have a working board that I can do hardware on, and then we know what to correct on the other board in order to get that working. So meanwhile, I'm going to be working on software and trying to figure out what in the holy hell is going on mathematically in this stupid thing in order to make this signal, this insane square wave, into some kind of an actual cromulent sine wave. It's maddening. I don't know what the hell is going on. It's so weird. And it kind of seems like there should be some capacitors on this thing in order to smooth it out. That little switching glitching is causing some wibbling and wobbling that we don't like. Well, actually, we probably won't be able to hear it. And under the other encoding schemes, we'll have to see what kind of waveforms it produces. Pretty cool stuff. We did some pretty cool stuff today, chat. We actually have a test program that Mutables did not provide a test program with their modular synth modules. There are echoes of one having existed in the past, and Emily Gillett took all that data out and then released all the information. So me building the synthesizer was like, the synth doesn't work, what's going on? And I had nothing to test it with. What we did today is basically the equivalent of that on a much less complicated scale, where we take serial prints and we tell the user everything that's going on. And in order to, that makes troubleshooting and finding the problems that we found so much easier. Historically, it's called as the first one and used a ton of outdated design elements. That's kind of interesting, though. Yeah, like a pin in time. Okay, I'm done. My brain is mush. We've been coding and rooting out issues and correcting things and soldering and scraping all day. I had a great day. You guys were awesome. I'll be back tomorrow, and we're going to go a little deeper into the code. In the meantime, I'm sure Uo's lab is going to go live at some point. It's never in time for us to raid him, but I got to go cook fajitas for everybody and then give my dog a walk. I need to walk the doggy around. But I'll be back tomorrow promptly, same bat time, same bat channel, and I will catch you then. In the meantime, you can contact me on where the hell is anything on this. What am I looking at? Oh, hold on. All my windows are all over the place. I need to dig out the. Where did it go? Where's Twitch? There it is. It's all the way over there. No, that's the wrong one. It was a feint. That one was designed to distract me. Oh my God. There's that one. Okay, there it is. There's Big John. Okay, we're home. Oh, you already did it before I got a chance. Pyro has just one thing in front of him. I have 10,000 windows. I finally found it. Hey, thank you guys for all the follows and stuff. Did I miss any subs? No, not since Ben Gizmo was the last person to give subs, and he gave 5 to the channel, so that was very nice of you indeed. Thank you so much for yesterday's contribution, because nothing happened today. Nobody did anything. I'll catch you guys later, and I'll be back tomorrow, and we'll continue from where we left off. Good progress today. What are you still doing here? Fuck off.